Hello everyone, welcome to Scalar's YouTube channel. I'm Ranal Bhattacharya and I'm currently working as an instructor with Scalar and also handling the front-end module. Today in this particular tutorial, we're going to learn each and everything about JavaScript. We'll be starting with functional programming, then we'll be going to asynchronous JavaScript, then we'll move to object-oriented JavaScript and a lot other topics. Right? But before we understand these topics that we are going to cover in this particular course, please make sure that you have subscribed to Scalar's YouTube channel so that you do not miss out on our upcoming tech content. And also, if you want to learn more about various technologies and frameworks, do check out Scalar events, where we conduct free masterclass that are taken by leading industry experts. You can find the link in the description. Now let us look at all the topics that we're going to learn in this tutorial. First, we're going to start with JavaScript. We'll be starting with the basics. Then we'll move to JavaScript functional programming, where we are going to learn about higher order functions, map, filter, reduce, how do they work, and how you can actually use them. We'll be also solving a lot of questions with them. Then we'll move to asynchronous JavaScript. In asynchronous JavaScript, we'll be understanding all about how JavaScript works asynchronously, right? They will be looking at callbacks, promises, event loop, call stack, everything, and we'll see how everything works together to give JavaScript that asynchronous behavior. Then we'll move to object-oriented JavaScript, where we'll be working a lot with objects. There we'll understand all about the this keyword, how this keyword works in node environment, in browser environment. Then we'll move to classes, constructors, prototypes, prototypal inheritance. Then we'll also see all of these methods that are associated with your objects in JavaScript that are call, apply, bind, and a lot of other things, right? So we'll be covering most important parts of JavaScript, which will be very useful for your interviews. And if you know all of these concepts, you'll be able to apply all of these in your projects or wherever you're working with JavaScript, right? So without any further ado, let's get started and let's create some impact. Because obviously, Node.js is a runtime environment of JavaScript. You can just say that Node.js will actually allow you to run your JavaScript code on your machine, and that is why it is called runtime environment of JavaScript. So Node.js is basically built upon C++, but it supports the language JavaScript. We write our code in JavaScript, all right? So we need to understand the basics of JavaScript first. So any programming language, right? Whenever you're learning any programming language, there are some basic stuff that you need to know, like declaring variables. How can you declare variables in JavaScript? How can we initialize arrays? How can we initialize objects? Right? How can we initialize? How can we create functions? And there is one thing in JavaScript that is known as scoping. So different variables, basically there are three type of keywords in JavaScript: let, var, and const. They all have different type of scoping, so we'll understand that also. There are two types of scoping: block scoping and function scoping. Let me write that again: function scoping. So before diving deep into Node.js, we'll understand the basics of JavaScript and we'll install Node.js first. We'll see how you can install Node.js. We'll see how you can run your first JavaScript program in your local machine. And we'll also see how does your browser runs JavaScript. Right? How does your browser run JavaScript? So basically there are two environments in which you can actually run your JavaScript code. First one is browser. JavaScript was by default built for browsers only, but then the Node.js came, and now with the help of Node.js, you can actually run your JavaScript code on your local machine as well. Right? So let's just start with the prerequisites that we need, that is the JavaScript basics. So first of all, what we will do, we'll actually go and we'll install Node.js. So we'll see how you can install Node.js for your Windows machine. We'll see how you can install Node.js for your Mac machine and of course Linux machine. So let's just go and let's just try and get started. So before installing Node.js and getting started with Node.js, working with Node.js, let us see that how does browser works with JavaScript, right? So here I am at my browser, right? And I'll just right click here and I'll just say inspect. Right? And here you can see an option that is console. You can just go to console and you can just write anything. Right? This should be JavaScript code, but so there is a method that actually helps you log something. I mean, that actually helps you print something on the console. This area is known as the console. So the method is console.log. So what I will write is console.log. And here you can say anything, right? I will say hello inside a string. And here what I'll do, I'll just press enter. So now you can see hello will get printed over here. Right? And also I can declare any variable. I will say let x equal to 2, and we can just go and we can again console.log the value of x, and you will get 2 here. Right? So in this way, browser will actually help JavaScript to run inside it, right? There are basically the concept of JavaScript engines that is helping doing all this stuff, right? So, but do you think that writing code in this console will help us? No. All right. So to write JavaScript code, what we'll be using is we'll be using an IDE. So I'll be using VS Code for that. You can choose any IDE that you prefer. All right, so just let me quickly start with VS Code. So here I've created a folder, node scaler. Inside this will be covering everything. We'll be writing all our code. So what I will do is I will just create a folder here, and I'll just name this folder environment. All right. So the first environment that we'll discuss is the browser. As you saw that we can run JavaScript code inside the browser, but what if we need an IDE? What if we need to write code and then link it to the browser, and then we'll see everything working there, right? So first of all, what you need to do is you need to create an HTML file and HTML file. So let me just name this for now as index.html, right? And then what I will do is I'll create a JS file over here. So let me just say demo.js. Now this index.html, if you are not familiar with HTML, I'll just ask you to go through, you will just need an hour or so to get familiar with HTML, right? So I'll not be teaching HTML here because this is a Node course. So I'll just take and I'll just write here the doc type HTML. Right? So this is basically the boilerplate code that we write. Right? So inside this, what we can do is we can link our JavaScript. So just to make you a little familiar with it, HTML, what does HTML does is HTML parses everything in your browser, right? Whatever you will write here, it will go into your browser's page, right? Which you have linked with it. So basically what we'll do here is we'll just take a link tag. Right? We'll just take a script tag. Let's just say script tag. And I'll say script, and we'll just close this. And inside this script, I'll just pass my source attribute as demo.js, which is this file, this file. And inside this demo.js, what I'll write, I'll just say console.log as we were doing before. We'll say hello from the browser. So what will happen over here is this index.html basically link this JavaScript file to this specific browser page that is linked to this index.html. So let's just open this with live server. I'll just open this with live server. And you can see this is an empty HTML page because of course we haven't written any element. There is no element that we have written over it, right? But notice something here. We'll just go to inspect, and as we'll open the console tab, you can see there is a message here that is hello from the browser, right? And what is that message? This is the same message that we have passed in the demo.js file. All right. So this is one way of writing JavaScript code, and this was the only way before Node.js for writing JavaScript code, because before Node.js, JavaScript was only made for browser. JavaScript used to work with browsers only. But now what we'll discuss Now we'll discuss Node.js. So let's just go and let's just start with Node.js and let's just first install it, right? So what we'll do is we'll just go to Chrome and we'll come here and we'll just type Node.js. So whenever you will go to Google and you will type Node.js, this is the first link that you will get, which is basically nodejs.org. I'll pin down this link in the description if you want, right? So you can just go to this link and you will see here that this is the homepage of Node.js. So what you have to do is, whatever is your system specification, if you're on a Mac, if you're on a Windows or anything, there is an option. You will get options here to download them. Or you can just go into a long-term support schedule and you will find in the downloads, right? In the download tab, you can find every version of Node.js that is available for you to download according to your system specification, right? There is Windows installer, there is Mac OS installer, and that's it. So let's just start with, as I'm on a Windows machine right now, so I'll just go and I'll just download this long-term support version, or you can actually install the current version. So current version is basically the latest release of Node.js, so maybe it can have some bugs or something like that, but the long-term support version is always useful for you. So you can just get started with long-term functions. I'll just go and I'll just click on this. So you will see that a file is file has started downloading here. I'll just wait for it to download, and now I can open this. Let me just open this. Okay, so this is the setup wizard of Node.js, right? So the setup wizard will install Node.js on your computer, right? Just giving some messages. You can accept the agreement, then you can do next, then yes, I want to install it here. You don't have to do anything here, right? You just need to click on next button. Then you do not need to install this chocolatey for now. It will just make your file size more bulkier. So what you can do is you can just untick this box and you can just start with Node.js. So we'll say next and you can just say install. So this setup wizard will start installing Node.js on your system. So let's just wait for it a little while. And here we go. So we have successfully installed Node.js on our system, right? And now to check that if you have installed Node.js on your system or not, you can just go to your command prompt. So let me just quickly go to my command prompt. And you can just go here and you can type node. So as I have typed node, you can see that welcome to Node.js version 16.15.1, right? And you can also type something here, like if I say console log, or if I say, let's just say let x equal to 2, right? Let y equal to 3. And what I'll do is I'll just say console.log x plus y. So it will basically print 5. Right? You don't have to worry about this undefined right now. I'll tell you later why this undefined is coming. So just ignore it for now. You can just see that the code is working. We can write our code here. We can do any calculation or stuff like that over here only. So this will basically show you that Node.js is actually installed in a system. Right? So of course we cannot write our code here. So what we'll do is we'll just again go back to our IDE. So you can come back to your IDE, and where we were discussing the about the environment. So first environment that we discussed is the browser environment. Now we'll go to Node.js. So I'll just create a new file over here, not a folder, a file, and I'll just say node.js, just for the name, right? Node.js. And inside here I can say console.log hello from Node. And what we'll have to do is we'll have to run this file now in our local machine. Now we are allowed, now Node.js is allowing us to actually run this file on the local machine. First, what was happening? We were only allowed to run JavaScript code over our browser, as you saw. But now, because of Node.js, we are allowed to run this file in our local machine. So let's just start with, we will just go to open an integrated terminal so that we can get the correct path where our file is, and we'll just go here. Let me just clear this. Yeah. And now to run a Node.js file, what command you have to type here is, you'll just type node and you will type the file's name. The file's name is also node.js. It's a node.js. And let's just press enter. So what you can do, so what you'll see is, you will see hello from node. So basically now what you're doing is you're running this code on a local machine, and that is what is Node.js is required for. It will actually allow you to interact with your local machine with the help of JavaScript, right? So these are the two environments that allows JavaScript to run. Right? Now let's just see the basics of JavaScript and how we can get started with JavaScript. We'll be using Node only to understand everything. We'll be using Node only to run every program, because going into browser and coming back, that doesn't make any sense. All right, so let's just start. So we have discussed the two environment in which we can run JavaScript, and now what we can do is we can create a new folder here with the name of JS Basics or JS Fundamentals, where we'll discuss all the fundamentals of JavaScript. So first of all, as we have seen, we have seen the first fundamental, the first basic point of JavaScript, that how you can print something on your console, how you can print something from your program, right? So in JS fundamentals, we'll be starting with declaring variables. So first of all, I'll just say this as one, or I'll just say that one underscore variables.js. And now let's start by creating some variables and see what are variables and how you can define variables inside of JavaScript. All right, let's just start. So there are basically three keywords by which you can initialize a variable in JavaScript. Now, what is a variable? Of course, whenever you're writing a program, what do you need? You need to store values. You need to store values for future use. And this is where variables come into picture. So what you can do is you can actually create some variables, like just suppose I'll say this is a variable A, and inside this variable A, what I can do is I can store any value, right? I can store 20. Inside this variable B, I can store hello string, right? There I can say variable C, I can say scalar is awesome. And I can also create one more variable where I can set true or false. Right? So this is how you can create variables inside of JavaScript. But have you noticed one thing here? I am never setting any type for these variables. If you're coming from the languages like Java or C++ or the statically typed language, for example. So these languages, they actually have this compulsion. That you'll have to always define a type for your variable. You'll always have to define a type for your variable. Like in Java, if you are actually initializing an integer value, right? So what you'll have to do is you'll write int a, and then you can initialize the value like that. So you're you're defining the type of this variable. But here what you can see is I've just wrote var a, var b, var c, var d, and I'm never initializing, or I'm never setting any type over here, right? So I'm talking about this in a very vague manner, but let's just go and write some code and see how is this working, right? So what I'll do is, first of all, I'll discuss the var keyword. So before ES6, before let it const, there was only one keyword by which you were allowed to declare variables, but there were some problems with var. We'll come to that later. So right now, what can we do is we can just say var a, and we can set this to 2. Right? We can come down, we can say var b, and we can set this to a string, scalar is awesome. right? And to print this variable, what we can do is we can just console.log a, and we can console.log b, right? And let's just go and let's just run this code and see what does this prints. So I'll just say node variables.js. We'll run this code and you can see it prints 2 and it also prints scalar is awesome. It is printing the variable a and it is printing the variable b as well. But notice something, we did not define any type for this variable. And this is what is the dynamic nature of JavaScript. Not only this, but what you can also do is that you can reinitialize this variable, you can redeclare this variable, you can reassign these variables, right? So let me just go and let me just do this. I'll say var a equal to, I'll say 30, right? So in other programming languages, this thing isn't allowed. You are not allowed to redeclare a variable, but in JavaScript you are. You can also reassign this variable, right? So first what you have done is you have assigned this a with a number, then you redeclared this a with a number. You can also do this. You can also redeclare this variable with a string, and JavaScript will allow that. And you can also reassign this variable with a different data type value. Like I just reassigned this with true. This is also allowed, right? So this is basically what is the dynamic nature of JavaScript, right? You can reassign, you can redeclare, you can do anything with your variables that you want. So if I just go into VS Code, if I just go into terminal and run this program again, so now you can see it's printing true as we have reassigned the value of a to true, right? And then it is printing scalar is awesome because the b variable consists of this value. But in different programming languages, you are not allowed to do this, but in JavaScript you are. So basically, the JavaScript is known as dynamic in nature because of this behavior. Dynamically typed language. We call JavaScript as a dynamically typed language. All right. So this was it. This was the first thing that we needed to discuss. Now, so we basically learned how to declare variables in JavaScript with the var keyword. But there are two more keywords that are let and const. So if we had this var keyword and if there is no need to specify any data type in JavaScript, then why do we need more than one keyword? That is the question, right? So there are a lot of problems with var. Like the first problem you can notice here is that you are allowed to redeclare this variable. You're actually redeclaring a, and you can redeclare this multiple times, and you can save any value inside of them. You can save a number string, and you can basically redeclare, you can actually reinitialize, you can reassign the values here with var keyword. But this sometimes becomes a security issue. This is a big security issue because, of course, if you have a large application and you're allowed to redeclare a variable, if by mistake anyone redeclares a variable, the value of that variable will change forever. And that is not something that you want, right? So this was the first problem. So this is the first problem with var, right? So let me just write this problems with var. Problems with the var keyword is that redeclaration is allowed. Redeclaration is allowed, which shouldn't be allowed, right? So to tackle this problem, let keyword comes into picture. We'll see how let will solve this problem. Now, the second problem with var keyword is it is function scoped. Now, what is function scoped? What is block scope? Okay, we'll come to that later. First of all, let's just solve this problem. So here, if you see var a, we have redeclared this so many times, and it is good enough to run our program. It will not throw any error. It will not show anything like that. But if we use the let keyword, let me just say let c equal to, I'll say hello, and I'll just print this over here. I'll just print this let C over here. So it will print hello here, right? But what I cannot do is I cannot do this again. If I say this 30, so you can clearly see that this is actually showing me an error, right? And this error is cannot redeclare blob scoped variable, because of course we can redeclare the variable when we are using var keyword, but this problem let is solving by actually not allowing us to redeclare any variable out here, right? So this is a problem let keyword is solving. So if we run this code now, and let me just type console.log C over here also, and let's just comment this code, and I can go and I can run this code now. So I'll just say node, this is the code, right? So I'll just say node variable.js. I'll run this file, and now you can see the terminal has thrown us an error, and it says identifier C has already been declared. Identifier C has already been declared, so you cannot redeclare this variable now. So this is what the difference between, this is the first difference between var and let is, right? But reassigning is allowed with let, right? Reassigning, redeclaration. This is basically redeclaration, because you can see we are actually redeclaring the variable. But if I just do this, this is allowed. This is allowed. Like any other programming language, reassigning is allowed, unless it's a constant variable, right? So here it is. Let C is equal to hello. We are console logging hello, and then we are reassigning this value to 30, and now it is allowed. Now it is allowed. So if we run this code now, if we run this code over here now, so we'll see node variable.js, and you can see hello and 30. All right. So reassigning is allowed. But there is a third keyword. There is a third keyword that is known as the const keyword. That is known as the const keyword. And as the name suggests, const is basically for defining anything as a constant, right? So if I just say const a equal to a, okay, I've commented this out, but still I'll say const d, right? So const d equal to, let me just say, welcome to Scalar. So now I will just print this here. And let's just run this code. So you can see hello 30, which is basically coming from this let variables, and then it's coming welcome to Scalar from this const. But what you cannot do here is you cannot redeclare this, and you cannot reassign this. In let, you were only allowed to reassign. You were not allowed to redeclare. In var, you were allowed to do both. You could also redeclare, right? You could also redeclaring, and reassigning. Both the things were allowed here. But with let keyword, there was only reassigning. You cannot redeclare this, right? So I'll just say reassigning. But with const keyword, nothing is allowed. No redeclaration, no reassignment. All right. So what you can do is you can just try this out by doing this const d equal to goodbye, or you can just say const d equal to, we can just reassign this as d equal to 50 or something like that, right? So this is not showing any error. This is not showing any error, but it is not allowed. So let me just quickly show you this. If I go and console log d over here, so what you will see, you'll see an error, right? Let me just run this node one variable.js. Okay, so we are thrown an error. The terminal has thrown us an error, and that says assignment to constant variable. This error will come here because we are actually reassigning a constant variable. A constant variable cannot be redeclared. A constant variable cannot be reassigned. All right. So this is basically about these three keywords of JavaScript. There is var, there is let, and there is const. And we actually discussed their first properties, right? That how do they work. So let me just erase this and let me just create a little table over here. So this is basically var. Okay. This is var, where you're allowed to redeclare and where you're allowed to reassign. You're allowed to do both. Then there is let, where you're only allowed to reassign. Then there is const, where you're only allowed to declare this variable for one time. No reassignment, no redeclaration. Alright, so this was the first thing that we need to learn about the variables and the keywords. There are 2 or 3 more differences that we need to see on var, let, and const, but they are for another time. Alright, so this is the basic of how you can declare variables, right? So just try and play around with it for a while, declare some variables, print them, alright, and do that stuff. And after this, we'll be moving to arrays and objects. So now let us discuss about arrays, that what are arrays, why do we need them, and what purpose do they solve, right? So array is basically a data structure. Array is a data structure that will help you to store multiple values. To store multiple values at once. Right? So array is particularly a data structure in which what you can do is you can store multiple values at once. Like let's just see how you can initialize an array, right? So you'll understand that better. So what I'll do is I'll just create a new file here. I'll say to_arrays.js. And so here we have created a file, and we'll just close all these files for now. All right. So yep. Let's just see. So first of all, we need to understand how you can initialize an array. So to initialize an array, there's a very simple way in JavaScript. You just need to declare a variable. I'm using let here. So I'll say let arr equal to just square brackets, right? So this is how you can initialize an array. And inside the square brackets, you can put all the values that you want, right? So let's just suppose that so I'll just write it right here, initializing an array, right? Initializing an array. Now let's just see how you can initialize and how you can put values inside an array. So for example, let's say that we have multiple fruits, right? We have multiple fruits, and we have a task to create an array of those fruits. So what we'll do is we'll just go here, I'll just type let fruits equal to, and how you can initialize with a square bracket, and inside the square bracket you can basically use single quotes or double quotes, right? There is no compulsion in JavaScript for using single or double quotes for strings. So what you can do is you can just use single quotes. This is basically recommended, and inside the single quotes you can name your fruit. Like suppose I give the name mango here, and then we have apple, right? And then we have orange, and so on. You can add as many as fruits as you want, right? So I'll just do this in a single quote. Alright. So in this way, you can actually create an array. Basically, what you're doing is you are storing multiple values at once inside this data structure, right? But there is a catch. There is one important thing about array is that these values will always be indexed. These values will always be indexed. What do I mean by that? Basically, the basic behavior of array is that it will actually give particular indexes to these particular values so that we can refer them at a later stage of time. And the indexing starts from 0. So basically, your first your first array element will start from the index 0. Your second element will basically have the index +1. That means it will have the index 1. And then this orange element, that is the third element, it will basically have the index of 3. So basically, what you can say that the longer your array is, basically the length of your array, right? So you will always have your index from 0 to n minus 1, where n is your last element, right? For suppose you have 0, 1, sorry, this will be 2. Little mistake, this will be 2. So 0, 1, 2. All right. So you have 3 elements, but it's starting from 0 and it's ending at 2. So basically you have 3 elements, but your index is what? N minus 1, basically 3 minus 1, that is 2, right? So this is how array will work. Simple as that. It will always have indexed, it will always have indexes that will basically help you to refer all your elements one by one, right? So this is how you can initialize an array. So the next thing that we need to see is that how can you access the element of an array. So what can you do is you can just go in and you can just say that you need to access this apple from this array, right? So what you can do is you can just go, you can say that let apple equal to, this is the fruits array. So what you will do is you will just say fruits. That means you are referring to this array, that bring me this array, and inside this array what I need is I need the first index. As we have discussed, this will be 0, this will be 1, and this will be 2, right? So we need the first indexed element, we need the first indexes element, the element that is at the first index. So what we can do is we can just pass square array, basically square brackets, and inside the square brackets we can just say 1, right? So what this will bring me is, when I will console log this apple element, let me just say apple element, and when we'll run this code, so now you can see this is actually logging apple, right? So what it has done is it has basically gone to the first index, it has looked at the first index, what value is there, it picked that value and it has returned it to us. All right, so this is the way you can access element from an array. So I'll just write here accessing element from an array, accessing particular element from an array, right? So this is how basically arrays will work. So there are a lot more things that we need to know about arrays, so let's just go one by one over them. So in JavaScript, now you have noticed here what we have done is we have basically stored same kind of data in this array, right? These three things are all strings, right? Mango, apple, orange, they're all strings. And in other programming language, in statically typed programming language mostly, there is a compulsion. There is a compulsion that an array can only have same kind of data. That means the data type of all the elements should be same. But in JavaScript, this does not stand true, because JavaScript is dynamically typed, as we have seen earlier. So arrays are also dynamic in JavaScript. So what you can do is you can actually store, like if I say let my array, I'm creating another array here. So inside this array, what you can do is you can actually store different values of different data types, right? So let me just say that hello, this is my first value, this is a string. Then I can also say 2 separated by a comma, right? So this will be my second element, basically the first index element. Then you can say true, this is my boolean value, you can also store it here. Then you can also say that we have stored a string, we have stored a number, we have stored a boolean value. Then you can also you can store a string, right? So there is no compulsion, there is totally no compulsion that an array should have same kind of data. There's nothing like it, it can have anything. So if we just console log this array, you'll see that it is perfectly fine and it will print, right? So let's just open Node. Here it is, right? So this is an array in which we have value hello, 2, true, goodbye, like that. So basically this is how array will behave in JavaScript. So when we'll discuss object, I will let you know that how arrays are also objects, right? But as we have not gone into objects that deeply, so I'll not confuse you right now. So what we can do is we can now see that how our different methods can work with arrays. How can you use different method with arrays to add element, to remove element, right? To manipulate your array a little bit. So let's just get started with the methods now. All right, so now let's just see what are the different array methods. What are the different array methods that you can use with JavaScript? Basically, that you can use to manipulate your array, to play around with your array, right? That you can use, array methods that you can use. So the first method that I will be discussing is the push method, right? So, okay, so what you will do if you want to add an element in your array, right? Adding an element in here, basically we're discussing that. So one thing is that you will go and you will statically add an element here, right? Like anything, false or something like that. You'll just add an element here, but not everything will be statically done, right? You'll have to perform some dynamic operations sometimes. So what you will do is you'll get a data from somewhere and then you'll have to add that to your array. So you will have to perform something like that, all right? So what you can do is you can use the push method to add a data in your array. So what push method will do is it will actually go to the end of your array and it will add the data there, right? So if you see hello, to, true, and goodbye. So these are the 4 elements that we have in our array. What if we want to add an element after goodbye, right? What if we want to add an element after goodbye? So we can just use a push method. So what we'll do is we'll just use my array, because that is the array we want to because that is the array at which we want to add the element, and in this my array we'll just use this push method and we'll just say anything, whatever you want to add, right? So if I say I want to add watermelon, let's just use this fruits array, so this will make sense. So I'll just use this fruits array and I'll add watermelon in it, right? So what will happen is basically this push method, what it will do is it will just take this fruits array and what it will do is it will just push watermelon. It will just push watermelon here after orange, right? So let's just run this code and see that. So node alright, so we haven't printed this fruit element. What I'll do is I'll just come here and I'll console log that fruit element also, fruit array also. So here you can see that mango, apple, orange, and here we have watermelon also. So what does push method will do? It will actually add an element, adds an element at the end of an array. Right? So this is what push method does. Of course, there is one method that is known as pop method. So as push method was adding an element at the end of an array, what pop method will do is pop method will basically do the opposite. It will remove the element, right? It will remove the element from the end. All right, so what we can do is we can just go here, we can just say fruits dot pop, and that's it. That's it. So fruits dot pop will automatically identify the last element that is inside this array, and now it will remove that element again. So it will remove that element basically. So let's just go and console log the fruits array again and see that this has worked or not. So what will happen is we have basically modified the fruits element with watermelon. So now our array has basically it has mango, orange, apple, and watermelon, right? So what pop method will do is it will just remove the last element, that is the watermelon, right? So let's just see. We'll just go here, we'll just say node, and you can see that this was the modified array when we pushed watermelon inside it and then we were popping it. So pop, what will it do? It will basically remove the last element from the array. So these were the two methods that are used to remove from the last and add to the last, push and pop, right? So now let's just discuss some more methods. Alright, so what if we want to add or remove any element from the starting of our array, from the basically starting of an array, right? So here push and pop were from the end of an array, but what we want to do is we want to add or remove element from the starting of our array, right? So for that we also have methods. So the first method is the shift method. Let's discuss unshift first. All right, unshift method. So unshift method, it will actually allow you to add an element at the starting of your array. So how will this method work is basically what we'll do is let's just take this fruits array for example again, and with this array we'll be using our unshift method. And inside this unshift method, you will have to pass what element you want to add. So I'll just pass a banana here, and I'll just go and will print the fruits array again. Right. So let's just go and run this code. I'll say node, and this is my file name. So now you can see that banana has been added at the first index, at the 0th index. So what unshift method has done is it has just taken this value and it has added this value in the first index of an array, that is basically the 0th index, right? So this is how unshift works. And if you want to remove an element from the starting of an array, what you can use is you can use a similar method like push and pop. There is unshift and shift, so you can use the shift method over here. So it will basically help you to remove an element from the starting of an array, right? So this is how they'll work, and let me just write something for this as well. So I'll just say fruits dot shift, right? So as I have write fruits dot shift, and when we'll console log this, what it will do is, you can guess, it will remove banana for you, right? So that's it. So here we'll go and we'll just try open integrated terminal node. So basically now you can see this updated array that banana has been removed from here, and this is because of the shift method. All right, so these are the four methods that we discussed: push, pop, unshift, and shift. What push will do is it will add an element at the end. Pop will basically remove an element from the end. Unshift will add an element at the starting of an array, and shift will remove the element from the starting of an array. So these are the four methods that we discussed. So let's just go further and discuss some more methods. So this is how basically arrays work, right? So there is a lot more stuff. There is a lot more stuff that you can do with arrays. Like you can also use higher order function. You can use spread operator to clone an array and all that stuff. But we do not have a better understanding of objects right now. So what we'll do is we'll just go through objects once. We'll understand objects once deeply, and then we'll move on to further, like in further videos we'll move on to different things you can do with arrays, right? So let's just move on to objects now. So what I'll do is I'll just create another file over here, and I'll say 3 underscore objects. So here we'll start with JavaScript objects, right? So let's just start. So in JavaScript, objects are basically a collection of data in key value pair. Yes, it's basically a collection of data for a particular object that will contain its properties in key value pair, right? So for example, let me just create an object over here. I'll say let person, right? Let person, and I'll initialize this as an object. To initialize a variable as an object, what you have to do is you'll just like in array you used to initialize an array with a square bracket. Here we'll just initialize an object with the curly braces, that is the curved brackets here. So this is how you can initialize an object. And now what you can do is you can just add some properties about this person object in key value pair. Like, for example, what can a person have? A person can have a name. So we'll just add a name. Suppose we added Adam. All right. Then you can separate this property with a comma. You can add another property with another key. Let us say age. And we'll say Adam is 23. Right. So this is Adam and here is his phone number. So we can say anything, right? For example, just I'm writing any random numbers here. So this is how you can actually create an object that will basically store details or properties of this particular object in the form of key value pair, where this name is the key and Adam is the value, age is the key, 23 is the value, phone is the key, and this random number is the value. All right. So in this way, JavaScript stores properties, right, for a particular object. Now, if you want to access any of these properties, what you can do is there are two notations. There are two notations by which you can actually access any property or any value inside of an object, from inside of an object. So the first thing is the dot notation. Like for example, if you want to access this name property from this object, what you can do is you can just say, I'll just console.log this, and I'll say person, I'll refer to this object dot, I'll get the name out of it. So person dot name. So let me just print an object first so you'll see how object gets printed. I'll print the whole person object first. So you'll see that this is how it will get printed. So I'll just say node and 3object.js here. So this is basically an object, right, where we have name, age, and phone. It's similar to this object, right? This object is basically printed here. Now, to access some particular properties from the object, what you can do is you can use the dot notation. So this is basically the dot notation, where you're actually calling a property by just adding a dot and the key's name, right? So here the object is person and the key basically is the name. So what it will do is it will bring the value out of that key. Person.name has the value Adam. So by this we are expecting to print Adam, right? So let's just try this. So you can see Adam is getting printed here. This is the object basically. We don't need this console.log anymore, right? So this is here, Adam is getting printed, right? So this is the dot notation, and there is one more notation, that is the bracket notation, by which you can access any property of an object. So let's just quickly see that also. Bracket notation. So what we'll do is we'll just console log. We'll again call the person object, and inside bracket, inside square bracket, in under string, right? Under string, what we'll pass the name of the, will pass basically the key's name, right? So here the key's name is name, age, phone. You can pass anything, but it should be inside a string. So here will pass phone, suppose, like that, and so it will basically bring out the phone key and the particular value of the key, right? So let's just run this again and we'll see what happens. So node. So you can see that this brings out the number value, basically the phone value, right? So this is how object work in JavaScript. This is how you can create an object in JavaScript. But not only this, object has so many different properties, right? So let's just see objects in a little more detail and can see what else we can do with object in JavaScript, right? So let's go ahead. So let me just take an example of I'll create an object, right? And I'll say this is Captain. I hope you guys are familiar with Captain America, right? So I'll just create an object of Captain America where I will be defining all the properties related to him, right? So what I will do is I'll just create let Captain America. So this is basically the object. So what all properties can Captain America have, right? So here he can have his first name. So I'll just say first name and I will initialize this first name. I'll give it a value of Steve. Then there can be last name. So I'll just give this a value of Rogers. Steve Rogers. This is his first name. This is his last name. All right. Very nice. Now see. Here I want to show you that inside an object, inside the keys of an object, you can set any value that you want. You can set any value that you want, right? So not only string or not only numbers, you can set any value that you want. Like if I go and I say is Avenger, and if I set this true, that's also perfectly valid inside of an object. So you can set string in the keys, you can set boolean in the keys. And of course, let me just say Captain America has friends, right? So you can also initialize an array inside an object so that you can have multiple values here. Like he had a lot more. He had many teammates. He had multiple teammates, right? So what I can say is I can just say Thor. I can say Tony Stark. Can say Bucky Barnes and so on. You understand the drill. So now you can also store arrays inside of keys. Then you can also sorry, not a semicolon, a comma. So friends, we can store array. We can basically store boolean values. We can basically store strings, and let me just store his age. So we can actually store numbers. Right? We can do all those stuff like that. We can also store nested objects inside an object. So let me just go and grab something as address. I have initialized a key named as address, and this address will basically have multiple properties, right? Address has multiple properties, state, city, pin code, etc. and all that. So we can also make a nested object inside of an object. So how can we do that? We can just do that by doing this, that we created an address, and we can say that this is an object, and inside this object we have multiple values, like we have state, not this dot state key, and in this state key we have New York, and for the city we can type Manhattan, or Brooklyn. I don't know. I mean, I'm just writing all this randomly just to make you understand. Right? So state New York, city Brooklyn. So you can just write your properties like that inside of an object. So you can string boolean. Basically, you can initialize an array. You can put a number. You can put a nested object. You can also create functions. You can also create function inside of an object. But I'll tell you about functions when we'll get to the functions. As we have not discussed functions, I'll not be discussing functions over here. All right. So this is how you can create an object, right? So now what we can do is, how can we access these values? How can we access these values? So there are two notations that we first discussed. One is the dot notation. The second one is the bracket notation. So what I'll be doing is I'll be using a dot notation over here to access some values. Like if I want to access friends, if I want to access this friends array, what I can do is I can just say console.log, and I can go to the Captain America object, inside of which I need friends, and so this will give me the whole array. But what if I need some specific element from this array? Like I need Tony Stark, for example. So here the array fundamentals will follow, the array property will follow. Like the array is always indexed, so if this is 0th index, this will be my first index. So what I can do is I can just go to friends, I can just say bring me the first index, right? And if you run this now, so you will see that Tony Stark is getting printed here. That is basically the first index of this array, right? So this is how you can basically initialize object. This is how you can basically set the key value pairs. And these are all the things that you can put inside a key of an object, right? You can also put functions, but we'll get to that later. And now you can print all this values, and you can play around with all these keys, right? So this is basically a basic structure of how an object is created inside of JavaScript, right? So there are different things that we can do here. That means we can say you can access you can also access this address nested object here, right? So this is the basic structure of object inside JavaScript. So now if you want to add something to this object, you can also do that. If you want to remove something from this object, you can also do that. We have all the means for that as well. So if you want to add something in this object, so what we can do is we can just refer to this object. And if you want to add a new property, like there is no movies property here. So what I will say is Captain America.movies, and I will make this as an array, and I'll just add some movies. I will add Age of Ultron, or let's just add Civil War or something. And let me just add one more, Endgame. Right. So you can see I've added 3 movies here. So now if I will print this object, if I will print this whole object, that is the Captain America object. So now you will see that a movies key will be added to this whole object, and you will also see these values there, right? Let me just run this again. So I'll just say node, and now you can see this, that in the end a movies property has been added with these values that we just pushed here, right? So this is how basically you can actually also add something to your object. Now there is a thing by which you can also delete something from your object. So there is a delete keyword that you can use, and you can just pass the object and you can pass the key. Like suppose I want to delete the age, so I'll just write delete, and I'll say from which object and what property I need to delete, and I can just say this, and this will basically delete this property from my object. So now if I console log my object, so you will see that that particular age property, you can see here is age property, but whenever I'll console this, it will not be there, right? So let me just go back and run this code. So now I can see now my object does not have the age property, it has been deleted. So this is how you can basically add your property. You can delete your property. If you want to update your property, like if you want to update is Avenger, so you can just take this property and you can set it to something else. Like if I go here and I say Captain America dot is Avenger, right, and I set it to false, that no, he is not an Avenger. So what will happen is that this will set it to false. So now whenever you look at this object, you will see that the value will be set to false. So if I run this code, sorry, I misspelled this, false. Alright. So now you can see that is Avenger is actually false now. So this is how you can actually update your object. You can add something to your object, you can delete something from your object. So this is the basic idea of object in JavaScript. We'll be doing a lot more stuff with objects further, but to start with objects, I think this much is enough for now. So yeah, so we have discussed variables, we have discussed arrays, we have discussed objects. Now the last thing that we want to discuss in this video is the functions. In JavaScript, how functions will work, what is the purpose of functions, how to initialize, how to create, how to declare, what are parameters, what are arguments. All that thing will be seen next, right? So I'll just create a file over here, and I'll say for_functions.js. So in this file, basically, we'll be creating functions and we'll be learning all about functions. So let's get started with functions now. Okay, so now let us discuss functions, right? What are functions? So let me just go to the board and just let you know what are functions. So basically, if we define functions, so functions are just a piece of code. Functions are just piece of code that runs when you call it, right? So it can also take inputs, and according to those inputs, whatever instruction that you have passed inside that function, it will take these inputs, it will process these inputs according to that particular instruction that you have passed, right? That what you have to do with this input, and it will give you a specific output, that is basically required out of it, right? So this is basically what a function is. It is a piece of code that will execute when you need to call it, right? You just write it, and after some time you can call it, so it will actually do the task for you. Okay, so for example, let's just go to our IDE, and here I have created a file for function.js, and here I'll be writing a normal function, right? So first of all, let me just write how will you declare a function, right? How will you declare or define a function? So what you do is you need to add this function keyword. You need to add this function keyword to declare or define your function. So here I will say function, and I'll say greet, right? Function greet, double brackets, and I'll open this. So this is your function body. This is basically your function body. You have defined the function, and now this is your function body. Here you can actually define your function, that what your function will do, right? So it will basically do, it will console log hello from scalar. So this is the task of this function, and as I said, this is a particular piece of code which you can call at any stage of a program, wherever you want, right? So I'll just call it here only. And how you can call it, you will just have to name this function, right? You just have to name this function, and I mean, you just have to take the name of this function and you have to add these brackets, right? So this is known as function call or function invocation. Right? So what it will do is whenever you will call it, it will actually refer to this greet function, and whatever is basically the task of this function, this will happen then, right? So let me just quickly run this for you. So I will come here. Okay, I have opened a lot of files. I'll just close everything. All right, and I'll just come here. I'll say function, and I'll say node 4. So this is how, and here you can see hello from scalar, which is basically the task of this particular function, right? So this is how, what you can do is, this is how you can create function, and this is how you can call your function. So this is known as function creation, function declaration, function definition, whatever you can say. And this is basically the function invocation, right? Function invocation, and this is your function call, or you can call it a function call, right? But this function can also take in inputs. This function can also take in inputs. So what we can do is, let's just create a simple function for adding two numbers, right? So what I will do is, I'll just say function, and I'll name this function as add, and here what I will do is, I'll pass a comma b. I'll pass a comma b. So this a and comma b, these are basically the expected input values that will pass when we will be calling this function, right? So at this stage of time, this a and b, these things, this is known as parameter of a function. Parameter of a function. Basically parameters of a function, right? A and b are the parameters of a function. Basically what is expected out of this function, that what it is expecting from you are the parameters. So it is basically expecting two values to be passed, and by getting these two values, what it will do is, it will basically add these two numbers. This will add a plus b, right? So let's just call this function, and now when we are calling this function, we have to pass the values that will go into a and b, right? So let's just say I am passing 2 and 3. So now when I'm passing these values, I'm passing these as arguments. These are known as arguments for these parameters, right? Whenever you are defining a function, you're actually expecting some parameters, and whenever you're calling it, you're passing the arguments for that parameters, right? So whenever you will call it, let me just comment this one out, and let's just focus on this body over here. So this body will take 2 and 3 as values, and will call this function. It will add these two values and will produce the output. So what it will give you, if I run this code, so it will give you 5, of course, right? So this is how you can actually create your function. This is how you can actually pass the parameters. This is how you can pass your arguments, right? So this is how a basic function works. So what I need you to do is, you just write the functions of subtraction, multiplication, and division, and let's just get done with it, right? So I hope you would be able to do that. I'm not doing it. You can easily do that. You just need to change this names, and you just need to change the operator here, right? So you can do that. So this is how basically a basic function works. But in JavaScript, functions also works as variables. So how will a function work as a variable, right? So that is basically the first class citizen concept of function. That is basically the function expression concept, right? So what we can do is we can also write a function like this. We can actually include a function inside a variable. Let me just say that we have created a function add here. So let me just create a function sub here. Like I'll just create a variable named sub, and what I'll do is I will create a function inside of it, and I'll say that it also takes 2 parameters, and it will also print the result of their subtraction, right? C minus B. So now what you can do is you can basically use this sub as a function, because now this variable has this whole function inside of it, right? And this concept is basically known as functions as first class citizens, or this is also known as the function expression, because what you're doing is you're actually including a function inside of a variable, and this is perfectly valid in JavaScript. You can do this. So now if you call this sub, with 3 and suppose 1, so what will be the output? It will be their subtraction, right? That will give you 2. So let's just see. Not 3, the fourth one. B is not defined. Okay, sorry, this is D. So you can see it's also giving the output as 2, right? So this is known as a function expression. Right? And this is how you write a normal function. That means a regular function. Right? So this is how you can actually do this kind of stuff. So there is one more concept that I need you to tell this, that is known as, so basically you must be thinking that what is the difference between this and this. Basically both are serving the same purposes. But when we'll go deep into the topics like hoisting and stuff, then you will understand that how our function expressions are different from regular function and what purpose are they solving. Basically, using this function expression are more recommended. It is recommended to use functions as expressions. And why is that? It is because of hoisting. So when we'll get deep into hoisting, we'll actually understand that why writing functions as expression is better than writing regular function, right? So this is how you can actually, these are the 2 ways in which you can actually create function, right? There is another type of function that is known as arrow functions, but we'll get into that a little later. So the next thing that I wanted to tell you is about the IPI. So IPI is basically immediately invoked function expression, right? Immediately invoke function expression. Like here you can see that we have defined a function here and then we have called it at a later stage of time. We have defined a function here and then we have called it at a later stage of time. But what is basically IPI? That you basically define a function right there and that is called right there. Alright, it will be immediately called. You will not have to call, you will not be allowed to call it at a later stage of time. You will be needed to write that function over there and it will call that function over there only, and it will finish doing its work, right? You cannot call it at a later stage of time. So that is basically an IPI, which basically immediately invoked. It is immediately invoked, right? By the name it's clear. So how can you create an IPI? How can you create an IPI? So let's just create an IPI for multiplying. So I'll just say multiply. And you have to add this round bracket first. You have to add this round bracket first. Inside this, you'll need to initialize your function. You'll need to pass your parameters, that what are you expecting out of it. And then you can normally define the function over here. So I'll just say console log, and I'll say that multiply these numbers, whatever will pass. But now you cannot call this like this. You cannot call this like this, right? This will throw an error. what you have to do is you have to pass your arguments over here. You have to pass your arguments over here. Like you have to pass this argument in the bracket outside, right? 20 and 30, suppose I've passed this, or I just passed 2 or 3, right? So whenever I'll pass 2 or 3 over here, what it will do is it will take this 2 and 3 as an argument, and it will pass into this parameter. It will call this function, and basically it will print a into b, right? So let's just go and let's just run this. So what I'll say is node 4, and here you can see that you have got the output as 6. That is basically 2 into 6. So these are all the ways in JavaScript that you can create functions. First one is the regular function, how you can create this. Second one is function expression, by basically including a function inside of a variable. And then third is the if. So if he has some limited applications, we'll discuss about them, that where this comes pretty handy, right? All right, so these are the things. And then there is a type of function. There is a new type of function that is introduced in ES6, that is the arrow function. So we'll be discussing over that as well. There are two kinds of nature in JavaScript. First of all, JavaScript is by default a single-threaded synchronous language. Now, what do I mean by that? We'll understand in this video. But there are some tasks that we can perform asynchronously as well. And what do I mean by that? We'll also see in this video. So stay tuned and let's start. Okay. So first of all, before diving into synchronous and asynchronous part of JavaScript and Node.js, right? What we need to do is we need to understand callbacks first. Right? What are callbacks? Because when we'll be understanding asynchronous JavaScript, we'll be needing them so much, right? So let's just go and let's just understand what basically are callback functions. So I'll just create a folder here. I'll say async.js. Inside this folder, we'll be talking about async.js, not dot. This is not a file, right? So async.js. So inside this folder, what we'll be doing is we'll be discussing all about asynchronous JavaScript. So inside this folder, I'll create a new file. I'll just say callback.js. So now we need to understand what basically is a callback. So a callback, right? So whenever you will read about functions in JavaScript, functions are also a kind of object, right? Because I will not go that deep into that here, but functions are objects. Functions are treated as first-class objects inside JavaScript. So basically what you can do is you can actually define functions inside of variables as we have seen in our previous videos. But also you can pass these functions as arguments inside of another function. That sounds pretty interesting, right? Let's see how we can do that. So if I create a function here, and if I say print name, right, and I'll just go and inside I'll console log the name here, and I'll pass this as a parameter over here, and I'll call this function print name, right? Print name, and I'll just say scalar. All right. So this is pretty much obvious that if I'll run this code, I'll get my output as scalar. That's pretty much obvious. And then I'll create a second function. I'll say function print tagline. All right, and here I'll just say console.log tagline, and I'll pass this over this parameter tagline, and I'll call this function here print tagline with a tagline that is create back. Cool, pretty much clear. When I'll run all these two codes, okay, tagline should be in capital. Good. So when I'll run these two codes, you'll see scalar create impact. But what if I needed to run this code only, print name, and I want to print the tagline as well as the name? I want both of these tasks to be performed by this single function. What I can do, I can pass this function. I can pass this function as an argument to this function. Sounds pretty interesting. Let's see how we can do that. So if I do this, if I say that, hey print name, take one callback also. Print name, take one callback function also, right? And in place of this callback, what we can pass is we can pass our function's name. That is the function that we want to be used as a callback, Okay, so we just passed print tagline over here. I'll call this CB over here and I'll pass our tagline create impact over here. And now what I can do is I can actually, print name. Print name should have been here. This is my mistake. So basically you have to pass, because we're calling print name, right? So print name is taking callback, right? So what we'll need to do is we'll need to pass print tagline here. I hope this is clear now. So I'm passing print tagline here. So what it is actually doing is, let me just show you what it is actually doing. What it will actually do here is that when you will pass this function over here, this is actually getting here. This argument is actually for this parameter, and we are calling this parameter over here. So for this particular invocation of the function, the callback will be this function, and this function will be called with this tagline, right? So I'll not need to call this function here, because print name function will actually be doing that for me by calling this callback. It will be calling print name of print tagline, obviously, right? So let's just try this and see if we are getting the output that is expected. So let's run the code, and we are again getting scalar create impact, because what has happened is this callback is getting called with the print tagline function. And this is how a callback works, and this is what a callback function is. So if I write a callback function, if I write the definition of the callback function, what I can write is a callback function, or basically a callback is a function that can be passed to another function as an argument. That's what a callback is. All right, so let's just go and let's just try and practice some more stuff with callbacks, and what all we can do with it. Let's just see. So not only this, you can actually pass whatever number of callbacks you need here, right? You can pass any number of callbacks that you want to invoke from a particular function. Like if I can pass another function over here. I can say this is CB2, and let me just create another function. I'll just say function print random anything, right? I can print anything, print random number or print a number. I'll just say print number, right? And here I will just go and I'll say console log math.random, right? And what math.random does is math.random basically generates a number between 0 to 1 randomly, any number it will provide, right? And I can pass this print number over here as well in the place of callback 2. So I'll just go and I'll call this callback 2, and I'll pass print number over here in place of where a callback 2 is expected, right? So I'll just pass print number over here. And now let's just run this code. When we run this code, you'll see that a random number, a random point number decimal number is generated, right? It is math.random basically generates a number between 0 to 1, right? So it is between 0 to 1, 0.29 and something like that. So when we'll call this again, so you'll see this time a different number will be generated. So what I'm doing here is I'm basically passing a function over here. I'm basically giving a callback over here. And for this callback, I'm calling this function print number. So this print number is actually this callback 2 for our case, right? So you can pass any number of callbacks inside a function. You can perform these tasks with them, right? So a callback function is basically when you're passing a function inside of a function as an argument, right? And that is to be called at a later stage of time. So this is basically a callback is. So what I will do is just try for some time and just create a calculator, right? You can just I just want you to create a calculator with callbacks, right? So what I want you to do is I just want you to write a function calculator. I just want you to have these parameters over here: addition, subtraction, division, multiplication, like that, right? And this should be the function. This should be the function. And you need to define all these as functions and call them as callback functions over here. So it's a pretty simple task, but if you perform this, it will help you to understand callbacks better. So please do this, and then we'll move forward. So if you're able to do this, well done. If you were not, don't worry, let me do this for you. So basically what I wanted you to do was I wanted you to create a calculator which will have all these functionalities, all this function, and I want these to be called as callbacks. So what I'll do is I'll just write function add addition. Let's just say I write function addition, and I'll just console.log a plus b, and as parameters I'll pass a plus b, a and b over here, right? And then I'll just copy this function, and what I will do is I'll make this a subtraction function. I'll say subtraction, and the logic will be a minus b. I'll again copy this function over here. I'll say multiplication, and I'll just say a asterisk b. And now what I want is I want to create a division function, and I'll just replace this asterisk with an oblique or a slash, right? So this is how I created these 4 functions. Pretty simple functions: one adds, one subtracts, one multiplies, one divides. And then I'll call these functions as callback over here. So what I can do is I can just call this calculator function here. I can just call this calculator function here. I can pass addition. And for addition, what I can do, I can call add. Right? So in this place, what function is going? Addition is going. So I can pass my arguments over here. So if I say 2, 3, and I run this code, you can see 5 prints here, right? And same I can do for subtraction, division, and multiplication. So I'll say sub 5, 3, the comma over here, right? Addition, sub, and for this sub I'll pass subtraction. Right? I won't be needing a comma over here. Okay, and then what I can do is I have passed one callback over here, and I'll pass second callback down here, and I can pass third callback down here with div, and I'll say I want to divide 6, 3. Right? And then I'll pass mul. That is basically my multiplication. So I'll pass here 2, 4, anything like that. Right? You can pass any value you want. Then what I'll do is addition, subtraction. The third argument is for my division function. So what I'll pass division over here, not here, here. And then I'll pass multiplication over here. So now if I run this code, what my calculator function will do is my calculator has all these arguments. Basically, these are all my callback functions, which are basically related to all these functions that I have created, right? The addition parameter takes this addition function as an argument and calls this here, right? And gives you the output, and same goes for every other function. When I will run this code, now you will see 5, 2, 2, 8, the result of my calculator, just a little calculator. Right, so this is how you can do this, and I hope you have understood callbacks, because please make sure that you have gone through all these concepts of callbacks, because callbacks are really important to understand the asynchronous nature of JavaScript, right? So yep, this was about callbacks. Now let us move to understand what does asynchronous and synchronous behavior means. All right, so first of all, let us take some real life examples and understand that what is synchronous and what is actually asynchronous behavior, right? So let's suppose that I'm teaching a class of around 200 people. There are 200 people in that batch, and I'm teaching them online right now. So let's understand that if this is the flow of my class, right? If this is the timeline of my class, right? If this is the timeline of my class, let me just create this with an arrow. So if this is the timeline of my class, so in this timeline, what I can face is I can face some doubts from different students, right? Suppose there are 200 people, and out of them 2 or 3 people, they have their doubts, and they got their doubts in between the classes. So what they will do is they will try to interrupt me in between the class, and they will ask their doubts to me. So what if I stop here to resolve first student's doubt? And it took me around 5 to 7 minutes, right? Then I stopped here for second student's doubt, and it again took me around 5 to 10 minutes to resolve this particular student's doubt. And then I come to third student, and I take his or her doubt, and it again took me around 5 to 7 minutes. So what happened in between this class is, for just 2 or 3 people, they had their doubts. What I did is I stopped in between these classes and took time. So Basically, what I did is I made 197 people wait for that long. 5 minutes, 5 minutes, 5 minutes. Let's just say I took 5 minutes to resolve each and every one of them. I basically wasted 15 minutes of other people, right? They were just sitting around there. They were just waiting because they didn't have that doubt. They were clear with that. So what I did here is this. In real life also, this practice is a little bad practice because what I'm doing is I'm stopping in between this class and I'm resolving their doubts. So this is basically the synchronous nature. This is the synchronous nature. And as I told you that JavaScript is a single-threaded synchronous language. JavaScript is a single-threaded synchronous language. So this behavior, JavaScript actually follows this behavior, right? So if you consider this as a single thread, if you consider this as a single thread, and if you consider all these doubts as tasks of JavaScript, so what JavaScript will do is, no matter if it will take much time, no matter it will take so much of time to perform these tasks, but JavaScript will stop here, will perform this task, and then will move forward. That's the basic nature of JavaScript. It's stopping in between, it's taking time to complete all those tasks, complete all those operations and processes, and actually making your application or making a program a little slow, right? But instead, imagine if I was taking a class again, right? I'm again in creating this timeline here, and this is a single thread. This is a single thread, right? So what I can do is I can just tell these people to wait for a while. I can just tell these people to wait for a while that, okay, you have your doubts, go and wait, right? Go and wait. And when I'll finish with my class, at last I'll call you three people. At last I'll call you three people. If this is my thread, at last I'll call you three people and I'll talk to you guys and I'll resolve your doubts, right? So what I did was I did not waste anyone's time here. I took my class, I went straight through with my timeline, and I stopped at the end, and then there were tasks that was going to take some time. I performed that task after the class. I resolved their doubts after the class. So imagine if JavaScript used to do that. Imagine if JavaScript was able to do this. So what it can do is it can actually save so much of time. Obviously, it does not take 5 to 7 minutes to resolve. I was taking a real life example. But in JavaScript, you can see even 2 to 3 seconds of waiting time is also very much for a large scale application, right? So we need to avoid that. So this basically is the asynchronous nature. Here, I did not waste anyone's time. So basically, when you compare these two scenarios, when you compare these two natures, what comes out is this asynchronous behavior comes pretty handy and comes pretty useful when you are developing large scale application with so much of data to process, right? I hope I'm clear with this. Let's understand this. Let's understand the asynchronous nature and the synchronous nature with JavaScript code. Okay, so let us understand what do I mean by synchronous behavior and asynchronous behavior with the help of code. So basically, if I write here console log hello, then I write console log scalar like this. Then I create a function test which generates a random number. So I'll say match.random and I'll call this function over here somewhere. And I'll console log after and I'll console log before over here, right? So here you can see clearly that I've written some random lines of code where I'm printing something, where I'm creating a function, I'm calling that function, this function generates a random number. So what you'll notice is all these lines of code will be executed one by one in a single threaded order, in a synchronous order. That means one by one. Nothing will be skipped and nothing will go above and beyond. Everything will go in the order. So when I run this code, you will see everything in the order. Before hello scalar, random number has been generated, and then after, right? So here you can see this is basically the synchronous nature, that everything is happening one by one in a single thread. But as we know that JavaScript is obviously a single threaded language, is a single threaded environment. So what we can do here to achieve asynchronous behavior, and how we can achieve asynchronous behavior, and why actually asynchronous behavior is needed, let's see that. So what I'll do is I'll just remove everything from in between, and I'll say that this is some code that is before my time taking task, and this is some code that is after my time taking task. And what will be my time taking task? I'll be reading some files over here, right? So to read some files, let's just take our FS module. So here I have created demo.js in which we are coding, and I have created two files over here which will be reading. All right. So what I will doing is const fs equal to require fs, and here as you know that how we can read a file, you have a read file sync method inside fs module from which you can read a file. You can use that and you can read any file from that. So I'll just say let data equal to fs.readFileSync, fs.readFileSync, and then pass one file over here, f1.txt, and the data that I've received, I'll just console log that data over here. So I'll say the data from file 1 is this. Alright, so here you can see I'm printing the data. So let's just run this file now. So I'll just go into the terminal, I'll say nodedemo.js, and here you can see before the data, so it's empty, I guess. So I'll just write I am file1 data, and then I'll run this code again. So now you'll see that I am f1 data. The data is coming from the file before and after printing, but notice something. This is again asynchronous order, because before is printing first, then the file is being read, then you're getting the data from the file, which is this, and then you're getting after, right? So whatever times you can run this, it will always give you the same result. But imagine that I have a file that has a very huge data, that has so much of information inside of it, as I've created this f2.txt. I've just put some random text here. This text doesn't mean anything. I've just put some random text here, and I have around 15 to 16,000 of text, like 15,517 lines of text over here, right? So what if I want to read this file now? Okay, so it's pretty much clear that how we can read this file. We'll say data2, then we'll say fs.readFileSync. I'll put f2.txt. And I'll similarly I'll print the data for this file as well. So file2 data is this, right? Now let me run this code for you again. So I'll open this in integrated terminal. I'll say node demo.js, and I'll run this code again. So now let's see what happens. Okay, so file2 data hasn't been printed. Why? Because we have not printed data. We should have printed data too, right? Now let's just run this. All right. So node demo.js. Now you can see this file is being read. This file is being read. And after reading this file, what are we getting here is the after. So what I'm trying to tell you is that the JavaScript is actually waiting for this execution, waiting for this operation to be finished before moving forward, right? It is not moving forward unless and until this data is completely read. And you saw that to read this much line of text, it actually took us around 2 to 3 seconds. If we run this code again, you will see, of course, it is taking more than 2 to 3 seconds, I suppose, right? So what do you think? Will it be efficient? Is this the efficient way of performing this task? Because what we are doing is we are making our program wait for a particular execution for more than 2-3 seconds, and 2-3 seconds is a very huge waiting time for softwares. So what we can do here now, asynchronous behavior will come into the picture, and we'll see how we can avoid this thing by using asynchronous behavior of Node.js. So let us just see that. So now what I'll do is I'll just comment this code for a while, and inside this fs module only, we have another method that is just the read file method. So let me just write that method for you, and let me show you that I have written this method, and when I'll hover over it, you will see that in the description you can read this actually asynchronously reads the entire content of a file. Here you can see it is mentioned over here. Asynchronously reads the entire contents of a file. So let us understand how does it will do it. So what I'll do is, so this read file method actually takes the file name, and with it, it's take a callback. It takes a callback so that it can call it later stage or at a later stage of time, and it can read the file. So what I'll do is I'll pass the same file over here. First of all, I'll pass f1.txt and I'll pass a callback with it. That's how you use this method. And then you have to define this callback. So I'll define this callback as function callback, and I'll define this. So this is basically an error first callback, right? There's always an error first callback. Error first callback means the first parameter will always be error for these kind of functions. So I'll just pass my error, because of course not every time you will be able to read this file, right? Sometimes it can happen that this file is broken, or you have passed some wrong file name, so you'll encounter an error. So for that, we need to pass this error parameter that will encounter any error, or if everything goes well, so it will print you, it will give you the data. So we will pass the data here, and then we can say if error, I'll just console.log the error, or else you can just console.log the data. This is file 1 data. Alright, so what I'm doing is I have passed a callback over here, and I have written this callback. So what it will do is it will actually work asynchronously. Now I will do a similar kind of a thing for file 2 as well. I'll do the similar kind of thing for file 2 as well. I'll pass, let me just say this is callback 1 and this is callback 2. So this callback is for my file 2, callback 1 is for my file 1, right? And now let me just run this code for you. So notice what will happen, right? So if I run this code now, you will see the file is being read, because obviously the file will be read. But what you'll also see is that the after statement, that is because the console log after statement has been executed first before reading the file. Okay, let me just show you that. Okay, let me run this again. It's not showing the full output over here. So let me just cut off a little bit of text from this file too. I'll just say I am file 2 just to show you, right? So then I'll go to this demo, and then I'll run this file demo.js. So now you can see the file data has been read later, and before and after has been executed first. That means what we did is, whenever we are encountering something as read file or these kind of methods which will take time, which will actually take time to get the data, what we are doing is we are making them wait. And we are moving forward with our code. So that's why what you're seeing is before has been printed first, because obviously it will be, and then these are all the asynchronous methods. As I told you that read file is an asynchronous method. What is asynchronous behavior? Asynchronous behavior is we'll make them wait. We will make them wait. We'll not allow them to execute over here. We'll make them wait. So what are we doing? We are making them wait, and we are moving forward with our next code on the line, right? So these two file readings are basically waiting to complete. When the JavaScript code will completely execute, then these two methods will be called. And how is this happening? This is a little bit confusing, that one method is reading synchronously, one method is reading asynchronously. What's the reason behind that and how it is happening? So to understand this, what we need to understand is all about call stack, event loop, callback queues, node APIs, and all that stuff, right? So let us go into the open board and understand diagrammatically that how all these things are working behind the scenes. Come on. So what I've done is I've cropped this code for you, right? So you can see that this is the code that we wrote to read, this is the code that we wrote to read our files. right? So this is first read file with a callback, this is second read file with a callback, and these are the two callbacks. Now we have to understand that how does it is working in asynchronously, right? So what we can do is, to understand asynchronous nature, we need to understand some concepts first, some terms first, right? So first of all, what we'll be creating is a stack. So here I'm creating a stack. And this here is the call stack. This here is the call stack. Every code of JavaScript, every line, every method, every invocation, everything of JavaScript that gives you the output goes here first, one by one, right? And then the call stack executes it for you. Second thing is what we need and what we have here is the node APIs. Sorry, I should have, yeah. So the node APIs. Now what are node APIs? We'll be understanding about them as well. And then, okay, so I'll write here node APIs. Then I'll create a queue over here. I'll create a queue over here, which is basically the callback queue. So I don't think you will be able to see this here. So what I'll do, I'll just create this a little. Yep. So this is the callback queue, right? Callback queue. And now the most important thing, the event loop. This is the event loop. So I'll just write EL over here so you will understand. This is the event loop. So basically this is a very important interview question and a very important concept to understand in the asynchronous JavaScript, right? So let's see how our code is working. So first of all, as I said, that everything that is that needs to be executed, everything that can be executed goes to the call stack. So now you can see the first line console.log before. So console.log before will just go inside the call stack, and the call stack will see, okay, so this is basic JavaScript code. This is a synchronous method. So let's just take this out and provide the output. So what JavaScript will do is JavaScript will do this, that it will execute this function and it will provide you with the output before. Simple as that. But now it will execute this read file method, and as you know that this read file is an asynchronous method. So what the JavaScript environment, what the node environment or your browser environment will do, that whenever it will encounter an asynchronous method, it will basically push it into this node APIs. This is not a stack, this is not a queue, this is nothing. This is just a collection of asynchronous functions that are available, that are present in your code, right? So what it will do is it will take this read file method, and it will throw this in the node API, and it will attach its callback with it, and the callback for this is CB. So we'll just write callback, and then it will encounter the second read file method. So what it will do is it will not execute it right here, it will make it wait in the node API collection, right? And then it will also attach its callback over here, callback. Right? So these two methods are now waiting with their respective callbacks in this node API. And then what we have this console.log after. So this console.log after will come here. JavaScript will see, okay, this is a synchronous method. So what it will do is it will just print the output over here. So now you have before, after, and then what will happen? These two callbacks will be pushed to this callback queue in any random order, right? Because this is not a queue, this is not a stack, so there is no FIFO, LIFO and stuff like that here. So what it will do is it will just put these callback in random order. So it can go CB and then CB2, or it can also go CB2 and CB, right? Both the combinations are available. And then there comes event loop in the picture. What event loop will do is event loop will see the callback queue and event loop will see the call stack, right? So what event loop will do is event loop will see the call stack, that if the call stack is empty, that means if the whole synchronous code has been executed, if all the synchronous code has been executed, right? So the callback must be empty to execute something, right? That you have seen that first before it is coming, then it is executing, then after it's coming, then it is executing. So call stack will not let anything stay, right? It will just execute it and it will just empty itself, right? So if the call stack is empty, the event loop will pick one callback from this callback queue in queue order, right? In queue order. So basically queue is first in, first out. So CB is first in. So this will be outed first. Then the CB will actually come here and it will execute. CB will come here and it will execute. So this CB is over. This CB is over and this will come here. This will execute. And what is CB? CB is this. CB is for f1.txt and it is actually printing the data for f1. So now here you will have your f1 file data, whatever is inside that, right? And then what you will have? Then the CB will be executed. And now your call stack is again empty. So event loop will see, okay, call stack is now empty. Now I can take up another function from this callback queue, another callback from this callback queue, and I can execute that. So what it will do is it will take CB2 now, it will put it here, it will execute this function, and this will actually give you the data for file 2. So now you will have your F2 file data. And this is the output that you saw, right? But the output can be these file data can be in random order because this is not a queue. So whichever callback can go first, right? And that will be executed first. CB2 can be executed first, right? So let me just show you that as well in the code. So what I'll do is I'll just write this code again. I'll just run this code again, demo.js. So now you can see that this time file 1 data and file 2 data, file 1 and file 2 are read in this order. But as we move forward, you can see that file 2 is read first at a time, and then file 1 is being read after a time, right? So the order can be random. Right? So this is basically how the asynchronous behavior of JavaScript is working. But what if we want the order to be also in a particular manner, right? That we want this to be in sync with each other, that we want it to be in a serial order, that first we want to read f1 data, then only we want to read f2 data. So we can also do that by using a serial combination, by creating them in a serial combination, right? And how we can do that? We just need to incorporate this callback with this callback. So what will happen? Basically, this callback will be executed first, and when this callback will be executed, only then this callback will be called after the data of this file 1 has been printed, because inside the function everything is synchronous. Outside the function read file is asynchronous, but inside this everything will happen in a synchronous manner, right? If you got that, do like this video. Okay, if you got that thing that I just said, do like this video, because inside this function everything is synchronous, right? So console log is synchronous, then we'll move to this line, and then when we will see that okay, read file is here, so now this callback to will be executed. So now if you run this code, what I'll do is I will just open this in integrated terminal. Now we'll run this demo.js. So now you will always see file 1 data, file 2 data, and now there will be no randomness in them, because we have made them dependent on each other. We have made callback 2 dependent on the callback 1. So whenever callback 1 will be called, only then after you can call the callback 2, right? So in this way you can make it in a serial order as well, right? And if you put this out, so this becomes your parallel order. So this is also a very important interview question, that how you can actually make your callbacks parallel and serial. How you can actually make them work in a serial manner, parallel manner, and all that stuff, right? So this is how you can do that. So what are promises? Promises in real life means a commitment, right? It's a commitment that somebody does to you, that he or she will do a specific task for you, all right? And on what does a promise depends on? if that particular person who has done that commitment to you fulfills it or not, right? So exactly like that, promises works in JavaScript as well. So let's understand what a promise is and let's write some code to gain some better insights. All right, so let's talk about promises now. So my mother always has this complaint from me that I do not do any household work, right? So what I do is I promise her that tomorrow I will bring groceries. Tomorrow I promise you that I'll bring groceries, right? So this is a promise. This is a promise that I made to my mother. This is a promise that I made to my mother. But if you notice that this sentence, right, or this promise is still a future value, still a future value. It has not been completed, it has not been processed, it has not even started yet, right? So basically, I'll bring groceries means that I have made a commitment to my mother that okay, this work will be done by tomorrow, but it has not been done yet. So right now, my promise is in the phase that is known as pending phase, or you can say pending state. So this promise right now is pending, right? When I'll wake up the next day, then I'll go to bring groceries, right? So if I am successful in bringing those groceries, if I'm successful in doing the task that I promised for, that stage is known as fulfilled state. That state is known as fulfilled state, that okay, I bought groceries. And if for some reason I forgot to bring groceries, or if for some reason I was unable to fulfill this promise, so then that promise is known as rejected. Then that promise will be rejected, and the phase it is that it is rejected, right? The phase it goes to is the rejected state. It basically work is not done, so I did not bring groceries. That means no lunch for me today. Right. So basically, these are all the three phases that a promises works upon. All right. So first of all, when I made the promise, nothing has been done till now. So that phase is known as the pending state because nothing has been done. If I fulfill this promise, if I fulfill this promise, if I have gone to the market, I've brought some groceries. That's basically the fulfilled state. So that promise has been settled. And then the rejected state, that I did not bring groceries, I forgot, or I was unable to bring groceries for some reason. So that is basically the rejected state. So these are the three phases, three stages of a promise. And whether this promise has been fulfilled or rejected, it gets settled. Right? Because obviously the promise has been finished. It has got fulfilled or it has got rejected, doesn't matter. It's settled, right? Some output you have got, right? When it has fulfilled, so basically I brought the groceries. When it has rejected, so I did not bring the groceries. So these are the two outputs, right? So basically, it can get fulfilled or it can get rejected. So on based on these two things, we can say that the promise has been settled. That means the promise execution of the promise has finished. So these are basically the four phases in which a promise works. So this was a very real life kind of an example. Now let's just write some code and understand how all these four phases works inside JavaScript. So now let's see how we can actually create a promise, and we'll see all the four phases of it. Alright. Inside this async.js folder, what I'll do is I'll create a new file. I'll say promise.js. Alright. So first of all, we need to know that how you can actually construct a promise, or technically the term is producing a promise, right? First of all, we'll see how to produce a promise. The first thing that you need to do is you need to create a variable. Let's say I say let my promise. I created a variable named as let my promise, and inside this I have to use the new keyword. Inside this I have to use a new keyword, and I will say new promise. I'll have to write promise like this. This promise object basically takes two methods, right? These are inbuilt methods that are basically resolve and reject, which are taken as callback functions. So here function resolve reject, like this. and here you can open your promise. So in this way you can actually produce a promise. This is a way you construct a promise. And then what we can say is, so there are basically two methods, one is resolve and one is reject. So as I told you that promise can be either fulfilled or it can be either rejected, right? So these two methods comes into picture. When a promise fulfills, the resolve will come into picture. When the promise gets rejected, the reject method will come into picture. We'll see that how these two methods can be used. So right now what I'll do is I'll just create two variables inside of it. I'll say const a equal to 4 and let's just say const b equal to 5, right? Or you can give any numbers. All right. Now what I can do is I'll just say I'll give it a set timeout function inside of it, a set timeout method. And inside this method, I'll just say, I'll write some if else statement. I'll say if a is equal to b, right? So I'll say that resolve my promise. I'll say resolve my promise, or else if these two values are not equal, I'll say reject them. Right? So basically this promise, the work of this promise is basically to check whether these two values 4 and 5 are equal. So if they are equal, basically it will resolve the promise. That means my promise will be fulfilled. And if these two values are not equal, I'll say reject my promise, right? Let's change it, this value into 4 for the first time. Now, so this is our promise. And for this set timeout, I'll just pass 2000 as a time. And then what I will do is I'll just go here and I'll just console log this promise here. Let's see what does it returns. Right. So let's just see what does it gives us. So I'll just run the code. And there is some error. Okay, it's my promise. Just a second. Not promise, it's my promise. Now let's run the code and see that it actually shows pending over here, right? Because what has happened here is that you can see that my promise equal to new promise. We have created this, we have produced this whole promise, and we are actually printing this promise before it has actually executed the result, right? So right now it has not gone into this set timeout and it has resolved our promise or rejected our promise. It has done nothing. It's actually pending right now because the promise is still in process of checking that if these two values are equal or not. It hasn't given us the output. It hasn't returned us any output right now. That is why this promise is right now in the pending stage, right? So this is the first stage of a promise that's pending. So how you can actually resolve or reject this promise, right? How you will get your output. So for that, we have some specific methods involved to promises, which are related to promises. Those two methods are basically then and catch. So let's see how we can use those two methods. So here you can see that you have resolve and reject as you execute a function. So these two functions will basically execute your promise, and to actually get the output you need to use two other methods that are known as then and catch. So let me just use those methods and make you see that how those two methods can work, right? So this was basically for your pending state, right? So let's comment this out for now. And now let's see that if your promise is fulfilled, how you can actually get the output. So let me just say inside this resolve, I pass a value that the values are equal, because if the condition satisfies, we have to show equal, right? So resolve equal, and if this gets rejected, we'll say the values were not equal. This is how you can work, right? Then let's go and talk about our fulfilled state, that how fulfilled state will work. So here, let me just say my promise. And what you can do is, as I said, that to fulfill, we have a special method that is known as the then method when actually promise gets fulfilled. So what I'll do is, I will just write my promise dot then, my promise dot then. And this then method basically takes a callback function, and inside this parameter, we can pass anything. Okay, so let's just pass data or let's just pass result. So this result is basically what will come from when the promise has been fulfilled. That means the promise has been resolved. So if you notice clearly, if you notice carefully, this resolve method and this then method, they are connected to each other, right? So basically whenever, sorry about this. All right. So basically whenever the promise will get resolved, whenever the promise will get resolved, the resolve method will actually send the data inside anything that we have passed here, like the values are equal. These data will be sent to the parameter, this argument, you can say, right? So now let's just see that what result do we have. So I'll just say console log and I'll just print the result over here. So let's see what result are we having. So let's just run this code. And now you can see after 2 seconds, because for the set timeout, right? After 2 seconds, you can see the result that we got is the values are equal. So that we know that our promise has been fulfilled. It has been resolved, right? Similarly, if I change the values, and let's say I have changed this value with 3. So now these two variables, these two values are not equal now. So A is not equal to B. So the else part will be executed. But in the else part, what we have written is that if the values are not equal, then reject a promise. That means the promise will not be fulfilled. So let's just try and see what output do we get over here. Let's run the code. And you see you're getting an error. That error is basically trigger uncaught exception, right, from promise. So let's read what it actually says. It says that this error originated either by throwing inside of an async function without a catch block or by rejecting a promise, right? So basically a promise has been rejected, but it's saying that whenever a promise is rejected, you should always handle this with a catch method. So what we can do is, whenever my promise gets rejected, I can similarly, as I used a then method, I can similarly use a catch method, and I can say catch the error, and then go and show the error. So what will be the error statement, right? Or what will be the result? All right, let's just say result for now. Failed result. So that you'll understand this better. Failed result. So what will happen is that when this particular promise will get rejected, this reject method, the value, whatever we are passing inside this reject method, will be catched by this catch method. So now let's see. The values are not equal. So let me just run this code once again. And after 2 seconds, you will see the values are not equal, right? So this has been rejected for now. So this is how what you can do. This is how you can actually go about handling promises. So basically you have produced promise here, and now here what you're doing is you're actually consuming your promises. So basically you're consuming your promises. That means whether they are fulfilled or not, right? So this one was basically a fulfilled thing, and this is basically rejected. So this is your fulfilled state. That promise has been fulfilled. So I'll just write fulfilled state, and here I'll just write rejected. And whether, as I told you, that whether it has been fulfilled or rejected, at last your promise will get settled. All right. So these are the 4 phases of a promise. All right. So this was a very basic example to start with, but now let's move on to some complex examples and see how promises work. All right. So let's take a scenario and then we'll solve this whole scenario with the help of promises. So let's suppose that you have a coffee shop. You have a coffee shop which serves coffee, right? So if you place an order for tea, juice, or soup or anything, you won't be getting your order accepted. This coffee shop only accepts the order which is coffee, right? So it only serves coffee. So here you are, right? And now what you will do is you place your order in this coffee shop. You place your order. So basically, as we said, that a promise is a commitment, right? So this coffee shop is actually returning you a token. right? A receipt, a token in the form of a slip, right? So we can say that that's a promise, because obviously the token is basically signifying the commitment that this coffee shop is making you, that okay, you have placed your order and now we have accepted your order, so take this token. So take this token, right? And you will have to wait for some time for your order to get finished, and then you'll be served with your coffee, right? So this is basically how this scenario will work. But as this coffee shop has accepted your order, that means the order you have placed was of coffee, right? That's why it has accepted your offer and it has given you a token. Now what will happen is, here you will have to wait. Here you will have to wait for your coffee to get prepared. So basically, we'll create one more promise. We'll create one more promise that will basically for the processing time. Will basically for the processing time. That will handle your processing time. And then after this promise will be fulfilled, this promise will be resolved, you will be served with your coffee. Right? So basically, the whole problem is that you have a coffee shop, you have to place your order, you have to get a promise back, then you have to create another promise which will basically wait until your order has been processed, and then when this promise will get resolved, you will be get served with your coffee. You'll get served with your coffee, right? So let's just try and solve this whole scenario with using promises. All right. So here what I'll do is I'll create a file. Let me name this as copy shop.js, right? And inside this file, we'll basically cover the whole scenario in by writing some JavaScript code. All right. So the first thing was that what we need to do is, there is a coffee shop that only accepts order for coffee, right? So what I'll do is I'll create a promise here, but that promise will be inside a function. So see, function place order, right? Function place order, and inside this place order function, I'll accept a parameter as drink. So whatever order I'll pass, that will go to this drink argument, drink parameter, right? So now I'll just create this function and I'll return a new promise from. So what I'll say return new promise, and this will have a function resolve and reject, as we saw earlier. These two are your executor methods. Then inside this, what we need to do is we need to check that if the order is coffee. So what we will do is we'll just say if drink, that means this argument is coffee, only then we have to resolve, only then we have to resolve this promise, only then we have to accept this promise, accept the order. And accepting the order means resolving this particular promise, right? Or else we'll reject the order, will not accept the order, so we'll just reject it from here. That's it. So this is our first promise that we created. Now, and let me just pass some message over here, that order for coffee received, other orders rejected, right? So in this we have created one promise over here. Now, as I told you that if the order is coffee, what we'll do, we'll accept this. So after accepting the order, what we need to do also is that after accepting an offer, we need to resolve this promise. So the promise will be resolved, and then we'll make the customer wait for some time. So that is basically your processing time. So for that, what I'll do is I'll create another function and I'll say the name of that function, I'll keep as process order. And this will also be a promise, because this value is also awaited. This value is also basically for this will be returned at a later stage of time. So we'll have to wait for this as well, right? So processing time. This is, so we are processing our order in this function. the function process order, and inside this what we will need to pass is we'll need to pass our order, that what order we have received, right? And then inside this process order I'll just return a new promise again, right? So let's just return a new promise from here and function, and we'll just say resolve. So here, as you see, that as we have accepted the offer, so that it's confirmed now that we will be serving the coffee, right? So that's why what I have done is I have just taken resolve here, because now from here we cannot reject the order, right? If we have accepted the order, we'll have to fulfill it. So that is why only resolve. So we can do this as well, that you do not always need to specify resolve and reject both. You can just use resolve also. So function resolve. New promise. So this will be in capital. All right. So return new promise, function resolve. And now what we'll be doing is we'll just say console log. And I'll just say order is being processed. And then what we'll see is as the order is processed, now what we can say that resolve with this message that when this promise will be fulfilled, that means the order is ready to be served now. So what we'll be passing here is that, let's say, the order served, right? All right, so these are our two promises that we needed to create to basically solve this scenario. Now let's see how we can actually get the output from them, right? The function place order has basically the drink. So what we will be doing is we'll call this function place order and we'll pass our drink. As I said, only coffee, the order for coffee will be accepted. So I said place order coffee. So as this function will have coffee, now when we'll call this function, this will actually check inside that if the drink is coffee or not, right? What we can say is we can change this with then. So I'll say place order and then I said coffee, and then I'll just say that function order, right? So I've received an order for coffee. Now it is ready to be resolved. It is ready to be resolved. So let me just say console.log and I say order. Right. So let's just see that if we get this answer over here as well or not. So let me just run this code. And now you can see order for coffee received, right? And now if I basically pass any other drink over here, if I pass any other drink over here, so if I pass tea over here, what do you think what I should get? Should I go to this then now? No, I should go to the catch statement, right? So we'll write that catch statement later. So now if I run this code, I'll receive an error, right? Because no other drink than coffee is accepted over here. All right. So this was our first thing, that the order is accepted. Now, after we have accepted the offer, what we need to do is we need to process this order, right? What I'll do, I'll just create let order is processed. I'm just creating a variable, let order is processed variable. And what I'll do, I'll call this method over here, this function over here, that is process order. Inside this process order, what we can pass our order placed. So let's pass our order placed over here. So now this process order will be called with this particular order, and the order placed, basically the order placed value right now has order for coffee received. So the order is process order, and here is your basically order for coffee received. So the coffee order is now being processed, and after it has completed processing, what we can do is we can return this particular variable. Over here, that order is processed. Okay, so the process has finished, right? And then what we can do is we are getting another output from over here, that is this resolve method. So now how can you handle this? So basically one promise handled this resolve method. So for this resolve method we have to create this resolve method, we have to create another resolve method, right? Another promise, right? So this is basically your another promise, and this will be handled with another then. So what we will do is we'll just use one more then over here. It has received your processed order, has received your processed order. And now what you can do is you can go over here and you can console log this particular or this particular answer that has been returned, right? So whatever is returned will be cached here, right? And then you will show this processed order thing, right? So let's just try and run this code. So now when I will run this code, you will see order for coffee received. So basically this promise has resolved. So order for coffee has been received. As the order for coffee has been received, we are passing this order to process order. The process order is taking the coffee's order and it is now processing it. And after processing this, it is returning the value, whatever has been the processed value. And then we are catching this processed value over here. So you can see order is being processed. So order is being processed is this console log statement. This console log statement, which is basically coming from calling this function. And it is returning that after processing the order, it is returning it. So resolve method has now the order. So the order parameter is now coffee, basically order for coffee. So it goes in there and then you're console logging the processed order value. So it is coming like order for coffee received and is served. And so now when you run the code, you can see the perfect output. So let me just rephrase this again. Let me just take you through this again. That what we did, we had a coffee shop that only accepts the order for a coffee. So we created a promise that will take coffee as an argument, and if it matches with the parameter, it will basically resolve it. It will resolve it. So after resolving it, as soon as it has resolved, we are basically showing the output from this. So order for coffee has been received. Then what we are doing is we have to process the order, right? So now we have created another function that is another promise-fied function that basically has a promise that actually processes your order. So we are chaining that here, right? So we are calling that over here, and we are chaining the output of this over here. So this after then, right? So we basically resolved a promise. Then after resolving that promise, we resolved another promise from the output through another promise, right? So this process is actually known as chaining of promise. Chaining of promise. This is how you can chain your promise, right? So these in this way, what you can do is you can chain your promises and you can basically jump from one promise to another. But just imagine this thing that if we used to do this, right? So if we are so if we keep doing this basically, right? Suppose that you have a larger scenario. Here you only had two things to handle. So you handled with the to then statement. But if you have larger scenario, what we'll be doing is you will be taking value from a promise. Then you will actually again chain it. Again take the value, this particular value. Then you will again chain it with another method of then. So it will become a very lengthy process, and it gets a little tricky to keep track of where you have resolved what promise, right? So to basically solve this scenario, you have one thing known as async await, right? So async await is nothing. Async await is nothing but a syntactic sugar for promises. They work exactly the same as promises, but all these things that you are using here, right? You are resolving, you are rejecting, you're using then, you're using catch. All right, so we should have used one catch method over here as well. We'll just say catch function error, whatever is the error you can show this, right? So for whatever reason the promise gets rejected, it will show in the catch state. You know that. All right, so let's talk about async await now. So as we have solved this whole scenario with using promises, right? So this was your solution with promises. Now what we'll do is now we'll try and we'll use async await to solve the same problem, right? So let me just comment this solution for now, but I strongly suggest you to please practice this because it gets a little tricky sometimes. to understand all this, right? So if you will practice this again and again, you will get to know that how things are working. So let's go and let's understand async await now. As I told you, async await is nothing but syntactic sugar. Syntactic sugar means it's just it works exactly like that, but just the syntax is easy. The way of making async await, the way of writing async await is easy, right? Is pretty simple. So all right, let's understand and see how we can write it. So first things first, the async await, these both are keywords, right? These are not any concept. These both both the words are just keywords, right? Which we have to use in specific areas to actually get the work done. So let's start with async await. So async await is basically that async keyword will always work with a function, right? So you'll always have to write a function to make async await work. Let me just write a function, and this function will be serve order. Name this function as serve order, and in front of this function, what you have to do is you have to add this async keyword. You have to add this async keyword. So inside this serve order, what we'll be doing is we'll just create variable and we'll wait for a particular process to complete, and then we'll just simply return the result, right? Let's see how we can do that. I'll say first thing, order placing, right? Here we are placing the order, and here we are basically showing how the order has been placed. So what you can do is you can just create a normal variable, let's say order placed, and inside this what you can call is you can call your place order method, right? So you have called place order method, and inside this place order method just pass copy, as we did over here, place order copy. So we are just passing place order copy, and we are saying that whatever the output that will be returned from this particular function will get stored into the order placed, right? So let me just console log this for you. Order placed, right? Let order placed equal to place order coffee, and let's just try and console log this. So serve order is a function, so I'll have to call this. Let me just call this function. Now let's see if we are getting the same output that we are expecting or not, right? Like we are expecting here order placed, we are expecting basically the value from inside the resolve method, that is order for coffee received. So we should get that here as well. Run code, and we are not getting it because we are getting a promise, because we are basically not waiting for that promise to fulfill. So what we have to do is I have to add the await keyword over here, async await. Now when you will run this, you will see order for coffee received, right? And after receiving, what was our next step? Our next step is basically processing the order, right? So here what we are doing is we are processing the order, we are returning the value, we are again chaining this with another then method. So we do not need to do all that here. What we'll do is we'll just say let processed order, and inside this processed order, what I'll be calling is I'll be calling my process order function. And inside this process order, what should be passed? Order place should be passed, right? And then again I can console log this and see if my order has been processed now. Let's just run this code. Now you can see order is being processed, but this function hasn't alright, processed order. Now you can see that order for coffee received, order has been processed, and then again I have a promise because I haven't used await over here. So I'll have to write await. Right? So this is how async await works. Await will basically wait for your particular promisified function to complete its task, whether it is getting rejected or whether it is getting fulfilled. Result. So whenever I run this code, you will see order received, order processed, order for coffee received, and is served. That's it, right? So you did not have to go through all this chaining. You did not have to go through all these return statement, chain your promises continuously, right? You just wrote some async await function, and you just waited for your promises to complete, and then you have your output. So this is how you can use async await in scenarios like this, right? But not only this, you can actually encounter errors here as well, right? So if you encounter error, right, if I pass soup over here, so what should be the output here? It should not place your order. So what it will do is it will basically throw you an error, but we haven't handled this here. What you can do is to handle error inside of async await, or while you're using async await, you can actually use try catch block. So what I'll do is I'll just say try catch. So this is basically try catch block, and you can actually place every code. You can place all the code from here inside the try block, inside the try block. So whenever any error will be encountered here, try block will actually send this to the catch block, and then you can here you can go and you can write your error, right? So let's just run this code, and now you see other orders rejected, because obviously you have passed in soup, so the order has been rejected. And if I pass coffee again, so it will start working. So this is how basically async await works. So what we did in this whole scenario is that we created a problem. We had a problem. We basically solved this with the promisified approach. We first saw how can you solve with promises, what is promise chaining, how you chain methods, and then we actually converted this whole solution to async await. We'll be talking about higher order functions in JavaScript. What are higher order functions? What purpose are they solving? How can you use them? And all that stuff. But before moving to higher order functions, I need you to do a very small specific task so that you will have a clear understanding of what we are trying to achieve here, right? So what I'll do, I'll just go over here and I will create a folder, not inside JS fundamentals, outside of everything. And I'll say HOF, which means higher order function. And inside this folder, I'm creating a file square dot. So the task that I want you to do is I want you to take this array. So let me just give this array, let num array, numbers array. Right? So this array will contain some numbers, just normal sequence of 1 to 6 maybe, right? Normal series of 1 to 6. And now what you can do is you have to write a function that will take this array, that will take this number array as an argument and will return the square of each element. Can you do that for me? Just pause the video and try to do this, and then we'll move on. So what you must have done is you would have written a function like this, add one, or sorry, we're squaring, right? So we will say squaring, square, and this square function will accept an array. Square function will accept an array, obviously. And then inside this function, we'll just loop through, let I equal to 0 to I less than your array dot length, which you will be passing as an argument, length, right, length, and then I plus plus. And inside this loop, you can just do this console log, and we'll say keep take the array element at every indexes, right, and just square them with it. We'll just we'll just multiply the same element twice, right? So I think you may have done up till here, right? And then what you can do is you can just call this function square and you can pass your num array, and this should give you the square of every number. So let's just run this code. So I'll just run this code over here, and now you have 14936. So you have achieved this. You have achieved. But what I'm trying to tell you is you don't need to write these functions by yourself. You don't need to write these functions because JavaScript has some of these functions inbuilt, and those functions are your hierarchy. So basically, higher order functions are the functions which will operate on another function, right? So I know I'm sounding confusing, but let me just rephrase this. I'll just write this and then we'll understand what I mean by it. So let me just write this. Higher order function are the function that operates on another function, right? Let me just give you a very small example. So we'll be solving this question only. We'll be solving this problem only, but now we'll be using a higher order function called as ForEach. So now we'll be discussing ForEach. So let's just try and use ForEach, that how you can basically use ForEach. Let me show you. So we'll be using this same array, that is your num array, and basically higher order functions are the functions which will only work with arrays, right? You cannot use them with any other data type. So this will only work with arrays. So here, let me just go and let me just grab this array, num array, and for this num array, I'll just go and I'll take my for each method, for each higher order function, right? And inside this, what I will do is it takes a callback. So that is what I mean by that it operates on another, because it takes a callback function. So the function will be this, and for this function we can pass anything, right? So let me just say that these are my array element, or I'll say just num. So what for each is basically doing is it is taking a callback function, right? It is taking a callback function, and inside this argument, what will be passed one by one, because this is for each, right? This is for each. So for each, what for each will do, it will take the num array, and one by one it will pass every element to this num argument, and will perform the operation that you wanted to perform, right? So then what we can do, we can just go and we can console.log that give us num in. That's it, right? So what this will do is this will go to num array. It will take this num array. Inside this num array we have 6 elements, 1 2 3 4 5 6, right? We have 6 elements. So one by one, this for each, what it will do is it will take every number from inside of that array. It will pass this to this argument. So that's what I mean by this function is operating on the another function. I mean the callback function which you are passing inside. And then what it will do is it will call this function. It will invoke this function with the particular number, right? Let me just make you understand this with a pen over here. So here is the num array, right? So first element is 1. So what for each will do, it will take the element 1, it will pass it to num 1. So now this argument contains 1. And then this function will be called. So when this function will be called, 1 into 1 will give you 1. Then this for each will again run, right? It will run up till the length of the array, right? So then it will move one index ahead. So when it will move one index ahead, you have 2 over here. So now your for each will pass 2 to this num argument. Your for each will pass 2 to this num argument. So 2 will be passed here, and this function will be called. So the log will be 2 into 2. That means you'll have 4, and same will go on until the end of the array. This is how an higher order function works, and this is how for each works. So let me just run this for you, and let's see that if we are getting our desired output or not. So I'll just go and I'll comment this thing out, and we'll just run this code. Let me just run this code for you. You have to see 149,625. So this is how an higher order function. Basically what it is doing, it is operating on another function, taking a callback, and it is operating. So this is what for each does. But there's a lot of higher order functions that we are going to discuss in this lecture. So this is basically for each function. You can just hit and trial, you can do anything with this method. But the important methods that we are going to discuss today are map. All right. Let me just clear my screen for you. So the important methods that we are going to discuss today are map, filter. We have already discussed for each. We'll discuss map, filter. Then we'll discuss reduce, a very important method. And then we have some small higher order function like sum, every, and find or find index of, and these kind of methods. So we'll be discussing all of these methods. So let's get started. So First of all, we have discussed for each. Now we'll be moving to, let me just change this file's name to for each so that you can refer this later. Now we'll be discussing about map. So let me just create a new file, map. What is map? Now we'll be discussing about that. So basically, map is very similar. Map is a very similar method to your for each method. Like if you notice that in for each, what we're doing, we're actually getting every element and we are performing some operations over that, right? So basically, your map also works similarly to that. So let me just go and make you see that how map works. So what we'll be doing is, so will loop through map will loop through every element of your array and will perform specific operations that you have provided, right? That you have provided. You will provide some operations, right? You will give some operations to perform over elements, and your map method will do that. And how it will do that? So what I'll do, I'll just create an array over here again, right? And I'll just go 1, 2, 3, 4, 5, and something like that, right? So this is an array of 5 elements. Now, what I want you to do is, what we want to do is, we again want to take out the squares, right? We again want to take the squares. So similarly, as I used for each, we can use the map method. So what I'll do, I'll just say array.map, and again, it will take a function because higher order function operates over another function, right? So this will take a function, and inside this function will pass our elements, which are numbers. So for that, I'm giving this argument a name number, right? And then what we can do is array.map. We are passing every element over here inside this function, and now what we want to do is we want map to go over every function, right? We want map to go over every function and return us the squared value. So what we'll do is we'll just return uh, num to get this to. And now what we need to do is we need to catch this in another variable. So what we'll do, we'll just say let squared. So squared array will be array.map. Array.map will go will take every element from this array. It will take 1, 2, 3. Similarly, as a loop works, right? And it will basically, what it will do is it will return for every element. It will return num into num. That means it will return its squared value in this array, right? So now what we can do is we can just go and we can console log the squared array. Let's see if it works or not, and we'll run the code, and you can see you got your answer in an array. You got the squares, but you got an array. So this is a very specific thing that you should note about map method. Map method will always return you a new array. So you must be thinking that we did this same thing with for each and we are doing this same thing with map, but what is the difference now? What's the difference? This is the difference, that for each will not return any array, right? So what I can do is I can just show you. If I say return num into num in for each, right? Return num into num in for each, and let me just catch this in a squared array variable. And now if you console log this squared array, right, and run this code, you will see it returns undefined. That means it's not returning any array, right? It's not returning anything. It's just there to console log or do some operations inside that only. It won't return anything. But this is not with map. Map will return array. So that's what I wanted to tell you. It will actually return you that array, and that will be a completely different array, because you can see this array won't be changed. If I go here and if I console log the array, so you will see the array remains as it is. 1, 2, 3, 4, 5 will remain as it is, but the squared array would have been changed with this particular result, right? So let's just run this code. Now you can see the previous array stays like that, and the squared array, which we have console log later, it actually contains the result that you expected, and it contains the result in a separate array. So map method will always return a new. This is the point to be noted. So this is map. So let's just do some more practice. Let's just do some more practice with map method. So what we'll be doing is we'll try. I have this array with me. All right, I have this array with me. That is our transactions array. Right. This is a transaction array which contains some transactions. Some are withdrawals, some are deposits. Right. So the withdrawals are basically marked with a minus symbol, so that we can know this is withdrawal, and the deposits are positive number. So this array we have with us, and now what I want you to do is I want you to change this withdrawal and deposit, whatever value you have. Just imagine that these are in rupees, and I want you to change this to dollars. Right? So how we can do that? So if you want to give it a try, just pause this video, give it a try. It will be good for you in practice, but I'm moving forward with it, right? So what we can do is we can just take this transactions array. We can say map. Inside this map, I told you that it works on another function. So we'll give another function. This will take every argument, every element from this transactions element in this argument. So we'll pass an argument over it. Let me just say transactions or amount. Let me just say amount. And now what we have to do is we have to convert this to rupees, right? We have to convert this to rupees, or we have to convert this to dollar, anything. So we need a converter for that. So let me just create one variable over here, and I'll say I want to convert this to INR to dollar, and the value that we have here INR to dollar. The value that we have here is 80 is the conversion rate, I guess, right now. So we'll be using the value 80. And now what you want to do is you just you can just take out all the amount, right? And we'll just return n, and we'll divide this by 80. So these are in rupees. If we divide all the n, right, that means our amount. And if we divide all this amount by 80, we'll get our prices in dollars, right? So let's just try and take, and we have to take this as another array. So I'll just say transaction in dollars. This will go like this. It returns amount divided by 80. So let me just console log this for INR to dollar transaction, right? Let's just run this code, and now you can see these are all your transactions in dollar form. Pretty simple, isn't it? This is how your map will work. Now if you want fixed amount, so there is a small method that is toFixed, right? So it will fix your decimal point values. So what you can do is you can just include this inside of a bracket, and then you can apply this toFixed method that JavaScript gives us, and I'll say 2. So this will actually give you up to 0.2 decimal value. So if you give this 0, it will give you a perfect one. So we'll just run the code, and you have got all your perfect. So this is just a small method you want to use. All right. So this is how basically map. Now we'll be moving to filter. We'll see filter. So about map, let me tell you, map will perform operations. Whatever operation that you will pass, it will perform on your elements on your array elements, right? All right, so let me just format this code for you so you can see it better. You can pause the video, you can practice it from here. We are moving forward, and now we'll see. Now, what is filter method? The filter method is very pretty much similar as map method. Just one thing is different here, that it works on conditions. Map method works on operation. Map method basically performs operations on your array elements. But filter method, as the name is clear from this method, that filter will be filtering out something, will be basically filtering out some array elements on a particular condition for you, right? So that is how filter method works. So let us just see and see how does filter works. So what I'll do is I'll just write a definition over here first so that you'll understand better. So basically filter returns a new array. Filter returns a new array, as map also does, as you saw in the previous topic. Filter returns, it will also return a new array, and basically it will return all those elements that matches the specific condition that you will provide. Will match the specific condition that you will provide. If the condition stands true, thing is, if the condition stands true, if the condition is true, will return the element for that condition, and if it is false, you will discard that element. Right? Like suppose you want to check for a number whether it is even or not, right? So what you will be doing is you will loop through the array. You will basically take modulus with 2. If it gives 0, then it's even. If it does not give 0, it's odd. You will do all that stuff. But with filter method, it becomes very, very easy. Let me show you how you can do it. So I'll just create an array over here. Again, a numbers array. Numbers. And this number, I'm just putting some random numbers over. Some are even, some are odd. Right, like that. So now what we need to do is, our task is to basically filter out this numbers array, filter out this numbers array in a new array, and that new array should only contain the numbers that are even. So what we can do is, with this numbers array, we can just use this filter method. Inside this filter method, again, this will operate on a function. So we have to pass a function, and let me just say the arguments are num. And what I'll just do, I'll just return where the number modulus, where the num modulus 2 equal to, that's it. So here you see, I'm passing a condition. I'm passing a condition that if this is equal, or only return if this value is, if this condition is satisfied, right? So if this condition comes true, only those numbers, only those elements will be returned. And if this does not comes true, if it comes false for elements, those elements will be discarded, right? This is how filter works. So what we'll do is we'll just take this in a new array. So let even array, I'll just say even array, and in this array we'll get all our results, right? Let me just run this code for you. And okay, we have not consoled this. Console.log. And even. So here we can run the code. And now you can see this is the output that you're getting: 2, 8, 10, 4, 56. All of these numbers are. This is how you can actually use your filter method. All right. So let's just move forward and practice some more stuff with the filter method. So what we can do is we can again use that transaction array that we used here. So I'll just get this transaction array. I'll copy this, I'll paste it over here, and please pause the video and try what I'm saying. I want you to basically take out all the positive values from this array, right? From all these values out here, I want you to take out. I want you to create a new array with using filter method, and I want you to get all the positive. Pretty easy, isn't it? So what you can do is you can just go, you can say let filter array equal to, or you can say let positive values array or anything. You can just go, you can say transaction. You can take these transactions, you can add the filter method over here. You can give a function, and inside this function what you can do, you can pass your amount, and what we can do is we will just return those amount. We'll just return those amount which are greater than. That's it. Right? And now what we can do is we can console log this filter. Okay. And now let's just run this. Run this code. Now you see that in this array, which is basically a filtered array, you have your array, and in this array you have all the positive. So what happened here is filter took all the elements one by one, checked for them, and for whatever values this condition became true, return those elements to the new array, that filter array of yours. So this is our basic filter method. Not only this, you can also chain these methods with each other. You can also change this method. Let me just go and grab a problem, and then we'll see how you can chain these methods and you can solve a specific. Let's go. Let's get on with it. After talking about filter, ForEach, map, right? Let's move on to how we can chain these methods. So what I'll do is I'll just create a new file over, and I'll just say chaining.js, right? And here I have an object with me. I have an array of objects with me. So I'll just paste that here, right? So this array of objects contains names which I have just randomly given ABCD, give the age and gender, right? So there are specific ages, there are specific genders, right? Some objects are male, some objects are. So what do we need to do is we need to take out age of all the men, or you can say males. Right? We need to take out age property of all the males from this array of objects. So how we can do that? By using map and filter. So what you will do, you will just go and you will just first of all what we can do is we can just go and we can basically filter every object according to gender. Filter every object according to gender, and then we can basically map those objects and we can take out their ages and do that. So how will be doing? So let me just say let male ages, or you can say let males. First of all, we need to take out all the males. So let males equal to, what we can do is we can just take this array, we can filter, we can put filter here, and we can just say for every function take every object, and if or you can just say return. You can also do return, you can also say if, and I will say if object dot gender, if object dot gender is equal to male, so what we'll do, we can just return true, right? Or you can do this like this also, that we can just go and directly we can return where object dot gender, right? Gender is equal to male. You can do this also, or you can do that also. You can use if or else also. That is perfect, right? So we'll just say return object dot gender equal to male. So in this males array, what you will get? You'll get all the object where the gender property is male. Where the gender property is male. So let's just run this code. We run this code and we got an empty array. Okay, because these are MF, right? So we'll just have to go M. Run. So now you have every men. Now what you can do is you can just go, or you can do this, that you can males dot map, and for every function you will take out every object from this males array, and what you will do is you will just return their ages. That return object dot age in another array, let males array. Right, so let male ages, I can say, and here we can console log this. Right, so let's just run this code, and now you have every age of male property object. But what you can also do is, instead of defining two different arrays, you can just chain this map method with this filter method here only. So what you can also do is you can just type map over here, and you can say function take every object that has been returned to you, and then you can just return object.ages from here itself, and you don't have to do this stuff now, right? So now if you just console males only, you will get your desired. Okay, undefined because ages, it's age. Like that. So you can also chain these methods with each other, and you can perform different tasks, right? Whatever is your application. So this is how you can use higher order functions, by chaining them with each other. All right. So we have discussed for each, we have discussed map, we have discussed filter, we have discussed chaining. Now we will discuss some small higher order methods, and then we'll move to reduce. So those methods are, let's just quickly discuss about some, every, find, and find, index of, and all that. So let me just go and write this here. Find.js. Find is a very small method, right? If you have understood map filter, and you have understood chaining for each, you won't have any trouble understanding find method. So what I'll do is I'll just take that transactions array over here again, and with this array I'll help you to understand find method. Find method is nothing. Find method will return that particular element which satisfy the condition at the first place only, right? At the first place, the first element that will satisfy the condition, find will return that, right? Find is basically used in when you are logging into your social media. So this your social media application, what it does is it goes and it finds your particular credentials in the database. Like there are a lot of things involved there, indexing, hashing, and stuff like that. We are not going that deep into data structures and all. I'm just trying to make you understand. Find basically does find what find does is find will be going to the database. Find will be going to where your data is stored, and it will just take out the first data that is stored inside that, right? All right. So now, after talking about filter, map, for each, chaining them, and all that, we will just discuss some small 2 or 3 higher order function, and then we'll move to reduce. So the first higher order function that we are going to discuss now is find, right? So find is a very small method, is a very pretty easy method, right? Find, what find will do is it works as filter only, right? It works as filter only, but it won't return every element that satisfies the condition. It will just return the first element that satisfies the condition, right? So how we can do this? Let me just grab this transactions array that we have. I'll be using this array only. Uh, Easy to make you understand with these kind of arrays. Right, so find method, what it will do, let me just write some code for you. Transactions dot find, I'm using find, and inside this find, what I'll say, that take every element, take every number, or we can say amount. So take every amount, and whatever amount, return whatever amount is greater than 0. Whatever amount is greater than 0, or whatever amount is less than 0. Whatever, I will say amount 0. So what it will do is, see, there are two amounts that are less than 0. There are two amounts that are less than 0. But we can use our common sense and we can pretty easily understand that first element will be this, that is less than 0, right? So it will return this element only. So let me just grab this here. Let first withdrawal, because in this array this is my first withdrawal. This is the first negative value, that means I have withdrawn this amount. So I'll just go and I'll console.log first withdrawal. And now you can see this gives minus 898, negative 89. So let me just quickly write the definition for you over here as well. So here is the definition, that find returns the first element of an array that satisfies it. That's it. That's it about find. Nothing fancy, nothing more to it. Now let's discuss two more methods that are small methods, sum and every. So what I'll do is I'll just create a file over here, sum.js. Run now. Okay. So let's again, I'll use my particular transactions array again. So I'll just copy this here. And now let's understand sum method. How sum method will work. So sum basically, sum actually works. It will return true, right? It will return true if one or more elements satisfies the condition. Minimum one should satisfy, right? Minimum one element should satisfy. So let's just try and understand this. So what I'll do is I'll just go and say transactions.sum. And inside this, I'll create a function. Then again, I'll pass all the amount and I'll say that, see, this transaction array is a little different, right? There are so many negative numbers. There are so many negative numbers and there's only one positive number. And there's only one positive number. So what I'll do is I'll just return if you find anything greater than 0. Return if you find any amount that is greater than 0. And I'll return this, right? Sum and every, basically they will return you your answers in the form of true or false. That if this condition exists, they will return true. If this does not, it won't return anything. So what you must know here is that sum method will return true. Sum method will return true if any of these elements satisfies this condition. So now you can see that 4000 will definitely satisfy this condition because 4000 is greater than 0. So what should be our expected output? Our expected output should be true. Let's just see that. So I'll just console log. It. Okay, console. All right. Spelling mistake. So log. Let's run the code again, and you have true over here, right? Because 4000 is satisfying the condition. But what if I do this? What if I make this 4000 negative? Now no element is satisfying this condition. Then what should be our expected output? Then it should be false. Run the code, and now you have, right? So basically the sum method, here you can read it, the sum method, sum condition, to get true or false based on a condition, it will return true if one or more than one element satisfies. If even one element, right? If even one or more than one element satisfies the condition, it will directly return true. And if no element satisfies the condition, it will return false. Okay? So this is basically your sum. Similar to sum, there is an every method. You must get that by now, that if sum is returning for any element, if any element is satisfying the condition, it's returning true. Every will be returning what? It will be returning for every element. If every element satisfies the condition, it will return true, right? So let's just try and test it out. So we'll just, I'll just create an every.js file over here. And in this every.js file, what I'll do is I'll just again take this transactions array with me, copy, and here is our every. I'll paste it here. And now what we can do is we can just see that here every element is negative. Here every element is negative. So let me just write something. I'll just say transactions.every. Transactions.every. I'll take a function. I'll say amount, and I'll return any amount that is less than 0. Check for amount that are less than 0. So now you can see that every amount is less than 0. Every amount is less than 0. So what should be our expected output here? What should be our expected output here? It should be true. Right? So let's just test this out once. Result. And let us run this. You can see it returns true. Every.js, we have run this file. But if I make any of these elements positive, if I make any of this element positive, that means this element will not satisfy the condition. Then what will every method do? It won't be returning true because one element is there that is not satisfied. Let's run this code and this is. So these are some methods like find, sum, every, map, filter, and for each. We also learned how to chain them. Now we'll be moving to a very important method, and it takes a little time for people to get this through. We'll be moving to reduce. So let me just create a file over here, and we will be discussing reduce. Let's get started. All right. So now let's start with reduce. So I've created a file over here, reduce.js, and in this file we'll be learning about. So reduce is a little tricky to understand sometimes, but trust me, it's very easy if you will understand this. So basically what reduce does is reduce will actually reduce your array elements in such a result that it will give you one single output, right? If you're coming from data structures, right, if you have solved a little bit problems on programming, so you must have done that problem of sum of all natural numbers. So what you do is you just take an array. What you do is you loop through every element of it. You keep a global variable as sum, and what you do is you keep on accumulating all those numbers in that particular variable, and then you return that variable, right? So you get the sum of all the natural numbers or all the numbers in the array that you have been provided. So you must have solved that problem. Reduce works just exactly like that, right? So let me just tell you how reduce works. So I'll just say that I'm creating an array over here, and this array has 1, 2, 3, 4, 5, 6, right? So this array has these numbers inside of them, and by using reduce, what we'll be doing is we'll be adding each and every one of them with each other. So we'll have the sum of this array basically, right? So if we calculate this, what should our output should be? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10, 15, and 15 plus 6 is 21. So we should get 21 over. That's our purpose, that's our objective. So what we'll do now, I'll just create a variable addition, right? And inside this, what I'll do, I'll say array dot reduce. Inside this, I'll say array dot reduce. Now, reduce is a special hierarchy method because it expects two arguments in a function that you'll pass inside. So I'll pass a function and I will be passing two arguments. One argument will be your accumulator. So I'll say ACC. That's your accumulator. And the other argument will be your values. The other argument will be values that will come one by one. And now what we have to do is we have to define this. To initialize this accumulator, remember when you used to solve the sum of all natural numbers question, what you did is you initialized your accumulator. You used to initialize your accumulator variable with a number 0, right? If you are adding, you initialize it with 0. If you're multiplying, you initialize it with 1, right? If you're remembering that. So what you can do is here you will pass the value of your accumulator, that is 0. So now your accumulator is initialized with the value 0. Your accumulator is initialized with the value 0. What you need to do now is just go here, create a variable updated sum, and you will just add your accumulator with your value. Just add your accumulator with your value, and you will return your updated sum. So what will happen here? What will happen here? Let's visualize what will happen. You have this array.reduce. You have passed the function. You have initialized your accumulator as 0. And now you're creating a variable updated sum and you're adding your accumulator plus value. So the value will be all the array elements. So first 1 will come here. First 1 will come here. And your accumulator is 0. And your accumulator is 0. So your accumulator plus value. Accumulator plus value. What will it will become? 0 plus 1. And that is 1. That is 1. So the 1 will be returned. 1 will be returned, and 1 will update the accumulator value. So now your accumulator becomes 1. Now your accumulator becomes, right? Then the second number comes as 2. So 2 will go to the value, and now what it will be added to? It will be added to your accumulator, and accumulator, now your accumulator is 1. It will be added to 1 plus 2, and that will give you 3. And then we are returning this updated sum. So this returned updated sum will update your accumulator also, right? It will update your accumulator also. So now your accumulator becomes 3. So now you have your accumulator as 3. Now next number comes, that is 3. Next number comes, that is 3. So this value goes to this 3 goes to this value again, and now you have your accumulator as 3. So value is 3, accumulator is 3. 3 plus 3 equals to 6. Now your accumulator becomes 6 because you're returning this updated sum, and this gets reflected over here. Now your accumulator is 6. It will be added to 4, right? Because the next number that's coming is 4. So 6 plus 4 will give you 10, and now your accumulator becomes 10, right? And this will continue up till the end of an array. I hope you get the idea how reduce is working, right? So this is how your reduce method works. Okay, so just a small question for you, that we have performed addition. I wanted to perform multiplication. So pause the video and try it by yourself, or let me do this. Multiplication. Array.reduce, same to same, will be copy pasting the code basically. We'll create an accumulator, we'll be creating a value, and just in this place of updated sum we'll be saying updated product equal to, now accumulator plus value, what we'll be doing is we'll be multiplying this accumulator with them, and we'll initialize the number with 1, because of course if we are multiplying, we cannot initialize this with 0, because then every value will become 0. And here we'll be returning what? The updated product. Right? Now let's just console these two values. We'll console addition and we'll console multiplication. So at last, what will happen is reduce method will actually accumulate all the values according to the condition that we have given. It will accumulate all the values to this returned updated sum, and at last it will return the value of the accumulator to the variable that you have defined, that is addition or multiplication, so that you will have your particular result, right? So then we can run this code, and now you can see 21 was our expected addition, so it's here, and 720 is the multiplication of all these numbers. So what reduce does is reduce takes two values, one is accumulator and one is the value that will be passed from your array, right? And it converts it into a single value according to your needs, right? Whatever you want to do. So here I'll write this: reduce all the elements in an array into a single value. It reduces all elements in an array into a single value according to the operation user has provided or is programmed with, right? So this is how your reduce method Let's just solve a little question with reduce method. It will also be related to chaining. So what I'll do is I'll just create a new file over here, reduce question.js. Right. So let me just take out that question for you. So what I need you to do is I just need you to do is that from transactions array, right? Again, we have our transaction. From the transaction array, filter out positive element and calculate the total amount. Right? Use filter and reduce to achieve this. What we have to do is from this transaction array, we have to filter out all the positive element and then we have to calculate the result, that how much money we have right now, right? Because every positive value is deposit. So the total will be how much money I have right now. All right. So we can do this. It's pretty easy, right? So what I'll do is I'll just create a variable known as balance. Please try it by yourself, pause the video and try it by yourself. And if you get stuck, watch ahead, right? So transactions dot filter, transactions dot filter, and for every amount, every amount will return amounts that are greater than 0. So now we have filtered every amount. We have filtered every amount in this balance. We have our positive values right now. Now what we can do is we can reduce, and inside this reduce, what we can do, reduce takes two values. Reduce takes one will be your accumulator, one will be your value, right? And now inside this, what we can do is we can say let updated sum equal to accumulator plus value, return updated sum, and let's initialize this the right? Simple as that. Or you can just say, if you don't want to create any variable, you can just return this directly. You can say return accumulator. That will work perfect. So let's just run this and see if we are getting our desired result or not. Balance. Here is your result, 13,800 rupees. I have this amount in my account. Right? So that's how basically reduce works. That's how filter works. That's how map, find, every, sum, chaining of higher order methods. From this video, we'll be starting with object-oriented JavaScript. Yes. So when you hear the word object-oriented programming, what are all the languages that comes into your mind? If you're coming from a C++ or Java background, you'll know what is object-oriented programming, right? But in JavaScript, object-oriented programming is very much different from the object-oriented programming that you do with Java and C++. But the concepts remains the same, right? So let's discuss that. What are all the topics that we should know in object-oriented JavaScript, and how can we learn them? So first topic that we need to learn is about the four pillars of object-oriented programming. Four pillars, right? So what are the four pillars of OOPS? Abstraction, encapsulation, then you have inheritance, and then of course you have polymorphism. Right. So these are known as the four pillars of any object-oriented programming language. But let me tell you one thing, that JavaScript is not considered as an object-oriented programming language. It is considered as a prototype-based language. Now, what do I mean by this sentence? We'll discuss about this, right? So the second topic that we will be discussing over here are classes and constructor functions. Or we can say classes and constructors and constructor functions. Right? So when I say constructor and when I say constructor function, they are vaguely the same, but they are different. Right? So we'll be discussing about what is a constructor function and what are constructors inside classes. Right? So we'll be looking at them separately. Then what we need to discuss is we need to discuss about prototype. And there is a concept in JavaScript that is known as prototypal inheritance. prototype and prototypal inheritance. And then there are some methods that we can use with objects, which are basically call, apply, bind. Right? So this will be the flow of our series or in object-oriented JavaScript. But before going to all these topics, first we need to learn a very important tool in JavaScript's object-oriented programming, that is the this keyword. So without understanding the this keyword, without you being comfortable with using this keyword, you won't be able to learn any of these topics, because every topic that we will basically discuss will always involve this particular keyword, that is the this keyword. Right? So in this video, what we'll be doing is we'll be looking at this keyword very deeply, and we'll understand how does this works, and when and how we are calling it, right? So basically the value of this depends on how you're calling it and where you're calling it, right? So we'll be discussing about all the methods in which you can, all the ways in which you can actually call this keyword, and we'll see about it, right? So let's get started with the this keyword first. So whenever you will watch any YouTube video or any, and whenever you will read any article on the particular this keyword, what you will notice is that they will teach you this keyword very effectively, right? But they would not cover all the cases of the this. So basically what they will do is that this keyword actually behaves very differently when you are working with your browser environment, and it behaves very differently when you're working in the node environment, right? Not only this, your this keyword behaves differently when you're working with strict mode in JavaScript, and it also behaves differently when you're working with the non-strict. That means you're writing the normal JavaScript code, right? So if you see, you can actually categorize the this keyword in four stages, right? In four different environments. And what are those environments? Let me just draw a line over here, or let me just take another color. I'll take the white color, right? And I'll just draw a line over here. Line. So this is one line. This is the second. So what we'll be doing is we'll be discussing this keyword in all its four environments. Right? The first environment, as I told you, that first environment we'll be talking about a browser. We'll be talking about a browser. Here we'll be talking about, right? And inside this browser, first thing we'll be talking about non-strict mode. Right? So we'll be writing basic JavaScript, and we'll see how does this keyword behave. So, and we'll also be seeing node with non-strict mode, and then we'll see browser with strict mode, and then we'll see node with strict. Right? So it's obvious here. All right. Browser non-strict, browser strict, node non-strict, node strict. In this way, we'll be learning that this keyword, so you will never have any confusion about in what environment are you working on. In whatever environment you're working on, you will know that, okay, in this environment, this keyword used to work like this, right? So this is how we'll be learning this keyword. All right. So let's start. So I'll be just opening my IDE, and we'll be starting with this keyword. All right. So I've created a folder named oops over here, and inside this folder we'll be discussing all about the object-oriented JavaScript. The first thing is that we need to discuss this keyword. So for this keyword, I'll need a separate folder inside which we'll be talking all about this. So let me just create a folder over here, and a new folder, this, right? So inside this what we'll be doing is I'll be creating a new file, and I will say this one dot. Okay, so inside this folder, inside this file, now let's start with learning this keyword. So now this can be called, this can be called in four ways. Generally, this is called in four ways. And when you call this in one particular way, you see different output, right? So the first way that we'll be looking at is simple console logging with this keyword. And remember, right now we are at node non-strict mode, right? So we are at this position. If you think about it, we are actually talking about node non-strict position. So we'll be filling this box right now, right, with all the 4 cases. So first case is when you console log this. When you console log this keyword, what output will you get over here? Right? So let us see. Here I'll come and I'll just say console.log this. And let's just run this code and see what output do we get. So I'll open this in integrated terminal. I'll say node this one.js. Let's run this. What are you getting? You're getting an empty object, right? So let's fill our chart. The console log this will give you an empty object. When you'll console log this keyword, it will give you an empty object. So this is basically a keyword that refers to specific objects at different objects at different times, right? Whether it has been called inside a function, whether it has been called generally, like it has been console.logged, right? And in this way, there are many methods in which you can, many ways in which you can call this keyword, and it will give you different outputs. Right. So first we noticed that saw that console logging this will give you an empty object. So let me just write an empty object over here. So this gives you an empty object. Right. Now let's move ahead. The second way in which we can call this keyword is inside a function. So let me just create a function over here that show value, just something like that. And inside this function, what I'll do, I'll console log this. And now I'll call this particular function, right? Let me just call this show value over here. And let's see. So I'll just comment this particular thing out. So this gave you an empty object. Right? I'll also be sharing the repository with you on the description so that you can go and you can check this code out. And you can see that on what particular way, what does this gives, right? So function show value, console.log this, and I'm calling this function show value. Let's see what we get while this is inside a function, right? So I'll just say node this one.js, and you can see you have got something that looks a little weird. What is this? This is basically your global object. This is your global object. Global object means inside this global object, every method, right? Every basically node method are defined, right? So you can see clear interval, set timeout, all the definitions for these functions. Then your micro task queue, as we discussed in our asynchronous JavaScript video, that there are your task queue, there are micro task queue, right? So all these things are inside this particular global object. So when you are doing when you're console logging this from inside a function, you're calling a function, so you can see that in this particular way, when you call this keyword, it actually prints the global object, right? So in this way, you have cleared 2 ways, right? So in node non-strict mode, first thing we console log this and we got an empty object. Now when we actually put this inside a function, so this inside a function will give you global object, right? Let's see the third way. The third way is basically inside an object. So we saw this generally we console log this and we saw that what it prints, what it gives. Then we saw it with a function. Now let's see it with a object. Let me just create an object over here. So I'll say let my obj, and inside this obj, what I'll do is I will try to basically set the value of this keyword, basically see the value of this keyword. So how can you do that? So you won't be able to do that without defining a function. So we will have to define a function inside our object. How can we do that? So suppose I have a name key, and let's just say the name is Adam, and then I have another key, right? Let's say I have a fn key. This is my function key. Inside this, I can define a function. So let me define a function over here, right? So in our objects video, we have talked about how can you also define a function inside of an object. So if you are not familiar with this thing, you should go back to that video and you can check that out. So now, inside this function key, we have defined a function. And now here, what we can do is we can console log this keyword. Right? And now what we'll be doing is we will be calling this particular function from inside this object. So how can you do that? You just need to refer to the object and you just need to call the key. Right? In this way, you can call this particular function. Now let's check what value does this particular thing shows. This particular way shows. So now you can see that it is actually referring to itself only. Right? So when I have called this function from this object, it is actually returning me the same object from which it has been called, right? So it is giving me my object completely again. So you can see that name Adam and function inside your function body, right? So this is your function and this is your name. It is returning you the same object, right? So what you can do also, right? I have called my object dot function, and now what you can say whenever you are calling this function, you can just pass this dot name over here. So as this keyword was giving you the whole object, now if I pass this dot name over here, what should it give? It should give the name property. It should give the name keys value, right? So let's just run this code, and you see Adam has been printed over here. So in this way, this keyword works with objects, right? So let me just go over here and let me write the third way, which are actually showing, we are actually viewing the value of this. So inside an object, we define a function, and from this function, we are seeing the value of this. So what it is printing the object itself. Right? Now let's see the fourth case, the fourth and the final case. In this case, what we will be doing is, let me just move this. So the final case is, right, so we have discussed the simple console log function, we have discussed object, and now we'll be discussing function inside a function, right? Let me just create one more object over here. Let my object 2, so like that. I'm creating an object, second object, right? And inside this, what I'll be doing is I'll again pass a name value over here. Let this name this time be Steve, and then let's pass one function 1, and inside this function 1, what we'll write is we'll write a function, and here what we will do is inside this function we'll create another function. So let me just create function fn2. So we have two functions now. One is this and one is this. These are basically nested function, one inside the other, right? So now here, if we console log the value of this keyword, right? Here, if we console log the value of this keyword, now what we will be doing is we'll have to basically call this function, right? We'll have to basically call this function to see the value. So what we're doing is we'll just call the fn2 over here. So that it has been called, the value will be returned, and then when we'll call then we will call the fn1 function, so it will give us the particular output. So what you can do is you can just go my object and you can call the fn1, right? And now let's just go and check that in this situation what value of this we will get, right? So let me just comment this thing out for a while, and let's check now. Let's run the code. And now you're again getting the global object. All right. So these are the 4 ways in which you can actually access this keyword. You can actually use this keyword, right? So console log function, function inside an object, and now object inside this object, one function inside this function, another function, and then you are using this. So what you're getting, you're again getting your global, right? So this is how we saw that this keyword basically in all the 4 cases with node and non-strict node. Now let's see what we'll get if we use browser's non-strict. Let us see that if we work in the browser environment, what will happen with this keyword, right? So let's go and let's check that out. So what I'll be doing is, inside this folder only, I'll be creating an index.html, because obviously to run a JavaScript in the browser, we need one HTML file. And then I'll just say that this is basically our doc type code, and I'll have to integrate one file over here. So let me just create one file, and I'll say this p.js, so that you will know that this particular file is for the browser environment, right? And now let me just go over here and let me just add this script. So what I'll do, I'll just come to the body, I'll say script tag, script source, and inside this source I'll just pass this b.js. So let me just go over here, this b.js, and let's just test once that if this is running or not. So inside this b, I'll just say console log. And let's open our browser. So what I'll do is I'll just go into my HTML file and I'll open it with live server. So now let's check. All right, so let me just close all these tabs, and then we can see inspect, and now in the console we can see, hey, so okay, the file has been linked and it's working. So now let's check that how this will behave with browser. So we'll be seeing those 4 cases only, right? These 4 cases will be using inside our browser. So let me just quickly pass this over here, and let's see that when we console log this on the browser, what value we'll get. All right, so let's check, and let's open this in the live server. So now let's check what value we will get when we are on the browser non-strict mode, right? The console, we're getting a window object, right? So what were you getting when you were using it with Node? You're getting an empty object. But now you see when you're using it with browser, you're getting a window object, right? So this is where people get confused, right? That they will see a video or they will read an article on Node, and then they'll come back and they will start working with the browser, and they will see that this is behaving differently. This is where all the confusion happens. So if you will watch this video, you'll never get confused while using this keyword. In browser environment, basically this keyword works as like something like this. This will return a window object for you, right? What is a window object? Window object is basically all the predefined methods, collection of all the predefined methods, right? In key value pair, basically this is an object. So you will always get all the methods, the cache storage, right? And all these methods like fetch, find, focus, and all those stuff, the local storage. So basically all the browser methods, all the browser services, right? So all of that things are basically contained inside this particular window object. So this keyword with using browser on non-strict mode will return a window object. So let's go into our chart and let's just write it. So browser non-strict, first case, when you're console logging this, it will print window object. Let's see what will it do when we'll try and use the second case. So the second case is this inside a function. So let's use that. So we'll come to our index.html, and now what we'll do is we'll just try and use this inside a function. So I'll just again write a function. I'll say show value, and inside this I'll console log this, and I'll just call this, and let me just comment this out, and I'm writing this window object because that is the output, right? So now let's see and what we will be getting. So now if I refresh this, now you see you're again getting the window object. All right, let me just open this again just to make sure that if this is the particular value or not. Let's inspect. You're getting the window object again, right? So if you're even calling it with a function, if you're calling this with a function, you will again get the window object, right? So when you're calling, when you're basically logging this, you're getting a window object. And when you're using a function, when you're using a function and you're using this keyword inside a function, you'll also get the window object again, right? Now, what will happen? The third case, when we'll be using an object, then a function, then this. So what will this return? Now, let's check it out. So what I'll do is I'll just copy the previous code from this particular file, and we'll run this code inside our browser environment, right? Let me just paste this and let me just uncomment this and let me just comment this. So here what we found that this gives you the window object. Now let's check with the object. So let's just open this with live server, inspect console, and you see you're getting Adam. That means you're basically again getting that particular object only. It is referring to that particular object. So if I remove this name, so you will see that you will get that particular object, that is name and the function. So it is again referring to the object itself. It is referring to that particular object from which we are actually calling this keyword inside from inside a function, right? So here in this particular case, you will again get the object itself, right? Let's talk about the fourth case now. That is basically object inside, function inside object, another function inside this function, and then we'll see the value of this. So what it will return, let's see. So what we'll do is we'll just go over here and we'll just I'll just copy that previous code of this object too, and I'll try this, and let me just comment this out. So here you also got object itself, and then this particular object. So now let's run this code and see what we will be getting out of this particular thing, right? So let's go and see. Inspect console, and now again you're getting the window object. Here you can come back and you can write here. In this way, basically this keyword works in the browser environment and in the Node environment. So in Node, these are all the four cases in which you will get different output, right? Empty object, global object, object itself, global object. Here you're getting the window object, object itself, the window object, right? And so you can actually make this chart, and you can basically try to memorize this, that when does this will work and how it will work, what value it will show. So this is all about browser non-strict and Node non-strict. Now let's talk about when we are working with JavaScript in the strict mode. Right? So what is a strict mode? Let me tell you very briefly what is actually the strict mode in JavaScript. Right? Let me just go to our IDE once and let's discuss what is a strict mode. All right, so let's see what basically the strict mode means in JavaScript, right? So imagine in JavaScript is a very indisciplined language, let me tell you. So it's a very notorious language because for basically checking errors and giving errors to syntactical errors, right? So let's see one example. If I do this, right? I just wrote A and I have assigned value 10 over here, and let me just console log this A for you. So notice I haven't passed any let, const, var. This A is not defined with any keyword, right? It's just A equal to 10. What do you think should happen? Should this give us an error? This should give us an error, right? But let me run this code and you can see 10 over here. The 10 has been printed, right? So these kind of errors are not governed by the non-strict mode of JavaScript, by the normal JavaScript, right? So what we can basically do to catch these kind of errors is we can use strict. So at the top of your JavaScript file, what you have to write is you have to just write use strict like this. So what will happen now is now we're actually enabling the strict mode in JavaScript. So what does the strict mode do? The strict mode passes a message to the browser or node, wherever you are using, whatever your environment you're working on, that hey, now we're at strict mode. So now we have to check for each and every variable, each and every function, each and everything in JavaScript that it is syntactically correct or not, right? So use strict does that. So let me just run this code now for you, and now you see that we're getting an error. It is saying that A is not defined. What you can now do is that you can just go and you can just put any keyword over here, and now when you will run this code, you'll see that it has started running again. So this is basically the strict mode in JavaScript. Okay. You can read more about the strict mode by going to the MDN web docs. There they have explained strict mode very deeply, right? So all right. So this was just the strict mode. I wanted to tell you that what it is, and now let's just move on to this key. Okay, so we have discussed node in non-strict mode. We have discussed browser in non-strict mode. Now discuss browser. Now let's discuss browser and node in strict mode. So what I'll be doing is I'll creating one more file over here. So I'll say this ns.js. So let me just write a comment that this keyword in node with strict, right? And this file is basically this keyword in browser. So let me just write a comment over here as well. This keyword in browser strict. And here what I'll say is this keyword in node non-strict. So whenever you will look at this code, you will have an idea that which file is actually containing what environment and what methods, right? What ways. So this keyword in node is node, right? In non-strict mode. Okay. So now just discuss this keyword in node in the strict mode, right? So what I'll have to do is I'll just go at the top, right? And I'll just say use strict like that. And then what we can do is we can perform our previous task again. So let's console log this in this particular file, console log, and let's just run this code. So what I'll do is open this integrated terminal. So we are basically working with Node. So I'll say this ns.js, and now you can see it is giving you an empty object. So pretty similar to what we saw in the non-strict mode, but it gives you an empty object. So node in strict mode, when you will console log this, it will give you an empty object again, right? Empty object, right? Let's discuss the second way. So this inside a function now, right? So I'll just copy paste the code from here. So this is the function, and let me just copy this code. Just paste this over here. Let's just uncomment. Let me just remove this. Right. So now let's see. So this is basically giving you an empty object. Comment this out and see how does a function behaves in the strict mode. Let's just run this code, and now you can see it is giving you undefined. At first, what it was giving you the global object, and now it is giving undefined. Right? So these are the things that you should be familiar with when you're working with the JavaScript on different environments, right? So now you can see that this function was giving you a global object. This case, node non-strict mode, the function case was giving you the global object, but now when you're actually using this inside a function, it is giving you undefined. So JavaScript works in weird ways, right? Now let's check the third way. So third way is basically object, right? A function inside an object. So let me just grab this code again. I've written it. So let's grab this code and inside this ns.js, we'll just write this, and what it is giving you undefined, right? Now let's just see that what this code will give. Let's run this code. I'll just run this file again, this ns.js. Oops, sorry. And now you can see it is giving the object itself again. So nothing new here, nothing different here. So when you are using a function inside object and you are seeing that this keyword, right, it is giving you the object itself. Let me write this. Check it. Let's check the fourth case now. When you're actually having a function inside object and a function inside that function, and then when you're trying to see this, what you will get now. So let me just check for this, and here we'll just copy this code and let's print this over here. So here what you got what did you got? What is this case? Okay, so object itself. And here what we can do is let's just comment this out, and let's see that while using this case what we'll get inside node strict mode. Let's just run this again, this ns.js, and you are again getting undefined. So see, when you were in non-strict mode, you were getting a global object and global object in the second and the fourth case. Now when you're at the strict mode, you are getting undefined and undefined. Right? So second and fourth case are basically different when you're working with the non-strict and strict mode inside node environment. Let's just work with the browser now in the strict mode and see how browser will work with the strict mode. Right? So this keyword will work in the browser string. So now what I'll be doing is I'll be using this same file, right? And I'll just create one new file over here. This be strict. So that means this browser strict .js. Sorry about that. So this bs.js. All right. Let's check for this particular thing. So let me just close all these files. Let me just open one more file. This bs, right? So let's use all this code. Okay. I'll just copy all this code, and one by one we'll see that how all this is working. So let me just comment this one as well again. So let's check for what we are getting when we are just console logging this keyword. Okay. Let me just remove this, and let's see. In our browser, we'll have to basically add this bs.js over here. Okay, now let's check. So we're using the strict mode in the browser. Let's see what happens. So let's go to the console. Okay, so you're again getting the window object. Pretty straightforward, nothing new here again. When you console log, yeah, this, you get your window object. Nothing new. Right? Let's check for the second case. Second and the fourth case is where you always notice some differences. So let's see that if we notice some difference over here or not. So inside a function, this. Let's check for the function now. All right, here it is. Let me just uncomment this and see what it gives. So here we saw window object, right? Let's check for this now. So what we will get in this case, we're again getting the window. Okay, what we're getting undefined again, right? You see, first we got the window object. Let me refresh this. Now you can see we're getting the window object because we haven't commented out the console log statement, right? So let's just comment out this, and let's see for just the function, right? So you're getting undefined. So pretty similar to the second case of node strict, we are getting undefined. Let's check for the third case now, when we'll be talking about a function inside an object. Right? Let's check for this case, and we'll go to our code, and we'll just and we will just comment. Let's just comment this code out. We got undefined, so it is pretty straightforward. Now let's see for this particular case, right? Object itself. And now let's check for this case. So we're getting the object itself again. So again, nothing new here. Object itself. And now let's check for the function. Basically, inside function inside an object, and a function inside that function, and then the this key. Now let's just check for the last case and see what happens for this particular case, right? What we're doing is we'll be commenting this particular thing out, and let's just comment this out, and let's see what happens. We'll go to our browser, and you see you're getting undefined again. They're getting undefined, right? So in this way, your this keyword works. You will notice that in every thing, right? In every in every environment, in every mode, this keyword behaves differently when it is called differently. When you're calling it with the function, sometimes it's giving a window object. When you're calling it in strict mode, it is giving undefined, right? And when you're calling it in node, it is giving an empty object. When you're calling it in the browser, it is giving a window object, right? So in this way, basically this keyword works. So it confuses a lot of developers, right? It confuses a lot of students. It confuses a lot of JavaScript developers that, hey, somewhere I'm using this keyword, it is giving another output. Somewhere I'm using this keyword, it is giving another output. So this chart will always help you to basically know that when this keyword will give what value. So as we are talking about object-oriented programming in JavaScript, so in this area of JavaScript, classes plays a very crucial role. All right. In this video, let's see how does classes works and how you can work with them. So now, suppose before going to all those classes, objects, instance properties, instance methods, and all these jargons, let's first understand why do we actually need a class? What is actually the purpose of a class, right? So let's take an example that you work for a car company, you work for a company that actually gathers data for different cars, right? And they have given you a task that, okay, we are actually sending you data of some cars, and what you have to do is you have to create separate objects for every car. What you will do, you will create an object like this. So car one, okay, name, suppose you got the data for a Ferrari, so you'll just give its name, you will just give its color, and then what you can do, let's say we have one more property that is top speed. So you will put your object like this, right? And now you will say, okay, that I have created one object. Now you got data for 50, 60, 100 cars, right? So what you can do now, you will just go, you will say car 2, and then you will go here, you will again write these properties, name, you will again write let's say you got a BMW this time, the color of the BMW is blue, right? And then its top speed is nearly 300 or something like that, right? So this is how you will be doing this stuff. But do you think that this is actually practical to be done for 50, 60 or more cars? Right? You will get bored. This is a very, very repetitive task. So why can't we just notice something, that are you actually using the same properties for a particular object? Like you're creating car 1, you're using name, color, and top speed. You're again using car 2, like you're creating car 2, you're again using name, color, and top speed. So this is the criteria on which your object should be defined. The values of these properties can be different, but this is actually the criteria. So why not, let's just create a class with all these properties, and from that particular class we can actually create different objects, right? If you are confused by what I'm saying right now, let's just go to the open board and understand. So let's see that what I actually mean. So what I'm actually trying to say is, that why not let's just create a cars class, right? Let's create a class of a car. And inside this particular class, what we can actually do is we can put all these properties, right? So what we can say that, okay, this particular class will have a property name, this particular class will have a property, a color, and this particular class will have a property top speed. So we created a class, and now what we can do is by this particular class, we can actually create objects. So I will just call this class over here. I'll say, okay, so my object is a car right now. My object is a car right now, and the properties I'll pass for that particular car will be here, right? So what I'll do is, like, suppose I got a Ferrari at first. What I will say that, okay, hey Ferrari, use this particular class and pass your properties to these particular properties. Pass your values to these particular properties, whatever your values are, right? And get created. Understood? Let's see this particular example in code, right? So let me just remove all this and let's go, and now let's create a particular class and understand how you can actually create an object from a class. So I'll just comment this code out over here, and what I will do is I'll just say class. So this is basically the class keyword that you use. Inside this class, what I will say, car, because this is a car. And how you can actually initialize a class is by opening your curly braces over here. So class car. So this is your class car. Now what you have to do is inside this particular class, what we have to define, right? Let's suppose we are actually talking about a car. So there are two things that basically goes inside a class. That first thing are the instance properties. For a car, what properties they can be? They can be the name, they can be the color, they can be the brand, they can be the top speed, and whatever property you're actually getting in your mind right now. Getting these four, so I'm writing these four properties for a car. And then you have instance methods for a car. So let's talk about instance methods. Right? So instance methods will be what actions basically your object related to this class can do. So what are those methods? Methods means functions, right? So a car, you can actually drive a car. So driving is a function. So I'll say drive a car, right? Then you can speed up a car. Speed up is a function, and slow down is a function. You can slow down a car, obviously. So now just imagine that if we can create a car class like this with properties and with methods. So what we can do is, like this, we won't have to create our classes, objects. What we can do is we can just say that, hey, car1, all right. So take help of this class, take help of this car class and pass your properties to these things, right? And get created. Just like that, you can create objects. Right? And here inside class, whatever object you will try to create are known as instances of that particular class. So that is why the name is instance. So instance properties, instance methods. So I hope I'm clear verbally, but when we'll code this, you'll actually understand that what I mean by all these things that I'm just saying. Right? So let's start and see how you can actually create a class, an object by using a class. So what I'll do is I'll just name this class as test, right? So that you can later refer to this particular class, and while I'll be pushing the code in the GitHub, you can actually take a look at this particular test class, that what are all the properties and what are all the methods that a particular class can. So now I'll be writing the car class. So let's see how you can write a actual class. So I'll name this class as car, and then I'll use a curly braces to open this particular class. And the first thing that you need to do when you initialize a class is to call a constructor method. So this is basically your constructor method. So what a constructor method will do, whenever you will try to initialize an object with the help of this class, the constructor method actually creates that particular object for you. And that's why the name is constructor, right? It actually constructs all those properties. It actually creates that particular object for you. Right? So let's see how this particular constructor function does that. So what I will do is just to make you understand first. So what I'll be doing is I'll just go in this constructor and I'll say console.log, hey, I am the constructor. All right. And now let's see that how you can actually call this constructor from inside this class. As I said that you can create objects related to this class. So how you can create an object, or I should say an instance. So let's see. So what you can do is, let's just say I will say let equal to, I'll have to use the new keyword over here. Right? So the new keyword will be used over here, and with this new keyword you will have to call this class. So I'll say new car. So what we are trying to refer over here, what we are trying to say over here, that this car1 will be created according to this class and it will have some properties. So those properties we can pass inside, but I'll let you know that how can you pass properties. And this is how you can actually call it. So this is basically now calling your constructor from here, right? So let's see that what output do we get. So I'll just say console log car1 and let's just run this code. So let me just clear all this output and let me just run this code for you again. So now I can see, hey, I'm the constructor, and then it is returning an empty object. Now, why this is returning an empty object, I'll let you know. But now you can see that it is actually calling that particular constructor, right? So this is what I wanted to show over here. Now let's come to that particular empty object thing that we saw here. So what you can actually do to understand that we can actually pass our properties now. Let's pass our properties. Let's see that how can we pass properties. So now a car can have these properties: name, color, brand, top speed. So let's pass some properties. So what I'll say is this dot name equal to Ferrari, and then I can pass this dot name, this dot color will be red, and this dot top speed will be 400. Let's pass 400 km/h. So this is basically how you created your object now from this particular constructor, right? And what does this keyword does here? This keyword actually creates a particular object, creates a particular empty object whenever you are actually using the new keyword to initialize an object from a class, right? So let's understand this again. That what is this keyword doing is, right? So what are you doing? You're creating a new car named as car1. So you're creating an object for here, for this, right? This keyword actually creates an empty object related to this particular object that has been created over here. And now what you're doing is you're actually saying this name, this dot color, this dot top speed. So what is happening is that this has created an empty object, and inside that empty object, what properties it will put now? It will put name, color, and top speed, right? So let's check that if we are getting these properties in that particular empty object or not. So let me just run this code for now. And now you can see that this car, which was at first empty, now has these properties, right? So this keyword is working like this over here, right? So this is actually creating an empty object, right? And from particularly using this keyword, you can actually put your properties for a particular object, right? So this is a particular object. Now, not only this, now you can create various objects. Now you can create multiple objects related to this particular class. But we have put static data over here. This data is static. This will not change. So what we can do is we can just clear all this from over here, and we can put parameters for our constructor, right? So as I told you that you're actually calling a constructor over here, so you can pass your arguments, and for those arguments, these will be the parameters, right? So let's see. All right, so I'll just say name will be a parameter, color will be a parameter, top speed will be a parameter, right? So these are all the parameters, and for these parameters, I'll say that take the parameter name, take the parameter color, take the parameter top speed, like this, right? If you're getting confused, let me just put a underscore over here so you will not be confused. right? Because obviously this dot name equal to name gets a little confusing. All right, the name, color, top speed. Right? So these are your parameters, and for these parameters you can pass your arguments over here, right? So let me just pass some arguments over here. I'll say Ferrari red. For the second argument you have to use a comma, see, because it is a function you're calling, right? And then you can pass your top speed. I'll say 450 kilometer per hour, right? And then what you can do is you can actually use this new class, right? I mean the new keyword and the class car, and you can create another object by this. So let me just create one more object. We'll just say new car, and we'll just put some different values over here now. So I can put BMW. I can say the color is blue, and then what I can say is I can say the top speed. So I will say the top speed is 400 kilometer. Like, so I've passed these two values, and now I can see that if I have created two different objects or not. Let me just run this code for you, and now you can see that here the constructor has ran twice because obviously we have called two objects continuously. So I'll just remove this so you won't get confused, and then let me run this. So now you basically have two objects over here. One object is for your car 1, one object is for your car 2, and they both are being made by the help of car class, right? So car has one object, car has second object. So Ferrari red 450 and BMW blue top speed 400 kilometers. So this is how you can actually use classes to create multiple objects. Not only this, there are a lot of things that you can do with classes. So let's see one more thing. As we have talked about instance properties, now we'll be talking about instance methods, that how you can actually create a method for a class and you can use that for a particular object, right? So let's see. So inside this car class, what I'll be doing is as we are creating functions, so we do not need to create the functions or the instance methods inside a constructor. We have to create them outside, right? And how we'll be creating them, we'll just name them. You do not even need to write the function keyword. So how you can do that, let's see. So let me just say I will be creating a method as drive. This is my instance method, right? So whatever functions you actually create inside a class are your instance methods. And inside this drive, what I'll say, I am driving at, let me just say console.log. I'll say, let me just use the template literals. I'll say I am driving at whatever the top speed is. Let me just pass my top speed over here, right? This dot top speed, because obviously we have to refer to this object, so we are passing this keyword, right? So this dot top speed. Now how can you call this particular method? All right, so let's call this method for car 2 and let's see what output will we get. All right, so I'll be just calling this method for the car 2, and let me just comment this console log statement. So I'll call this method for car 2. I'll say drive, call the drive method. Let's run the code, and now you will see I'm driving at 400 km per hour because the top speed of this particular car, the BMW car, is 400, as you can see that we have mentioned here. And now when I will call this method for car 1, let's see what does the output we get, right? Now I'll get I am driving at 450 km per hour because that is for that particular object. So this is how you can actually use different objects, and you can actually basically, if you see, this is actually just like that. The car is just to tell you that what properties should this particular class have. So this particular class should always have these cars properties, right? That are name, color, top speed. And according to this particular class, you can create various objects, various instances for this. This is basically what your object should expect. What properties should your object have? So the car is your class, and according to this particular class, your car 1, car 2, car 3, they should have their properties and methods. Obviously, you can define your properties like this, you can define your methods like this. We won't be stopping over here, right? So we'll go a little further and we will discuss inheritance over here. So there is a concept known as inheritance in JavaScript, and this is a right time to actually discuss inheritance. So let's see how does inheritance works. All right. So to understand inheritance, inheritance is a very common term that you may have heard in day-to-day lives. Inheritance is basically what happens is that suppose that your father and then your grandfather, and then here is you. Right? So what has happened is that your the last name of your grandfather has been inherited by your father. The last name of your father has been inherited by you. That means you have just inherited your grandfather's last name. They're basic. So what you are doing, that generation by generation, that particular property has been passed, right? From from your grandfather to your father to you, right? So basically from your parent class to the child class to the child class, right? So this is what I mean. So let's take it. This was a very basic example, and let's take it in terms of a problem, right? Let's suppose that we have a person class, we have a class student, and we have a class teacher, right? So these are the three classes that we have. So a person class can have a name, age. These are the two properties that a person can have, suppose, and gender. Let's give a third property, name, age, and gender. Now the student class can have marks, and the class teacher can have student strength, right? So student strength, basically how much students a teacher teaches, right? So these are the two properties that they have. So just imagine one thing, that we have a person class over here which has the property name, age, and gender. So will it be practical to define name, age, and gender properties over here as well, or here as well? Because obviously student and teacher are also persons, right? So they can actually have these properties from this class as well. So why not just give these properties from this class to this particular class as well, and to this particular class as well? So what are we actually doing is we are actually getting these properties from this class to these child classes. So in this way inheritance works. So what is a person? A person can be called as a parent class because you are inheriting the values from this, right? And you can call this student and teacher the child classes because the properties are getting inherited by them, right? So this is how inheritance works. Now let's just write this in code and understand this. All right, so let's continue with that example only. So what I'll be doing is I'll be creating a class. So I've created an inheritance.js file over here. A new file. We'll be taking a new example to understand inheritance, right? So class person, and let me just say that this person, what I'll be doing is I'll be creating a constructor for him because this is the first step of creating a class, and I'll say this dot name will be let's pass a name parameter over here and age parameter over here, and let's pass the gender parameter like that. So this dot name will be underscore name, and this dot age will be underscore age, and this dot, sorry, this will not be underscore, this will be this dot age because this is the property, right? Gender will be underscore gender. So these are all your parameters, these are all your properties. We have defined a class person. Now you can create an object for a person, right? So what you can do is I can say let person1 equal to new person, and the name of the person is Adam, age of the person is 25 suppose, and the gender is male, M, right? Like that. And now you can see your person1, and now let's just print the output. So now you can see you have an object with the class person of by the class person, that is name Adam, age 25, and gender M, right? So this is how you can actually create your object with the help of classes. This much we know. Now what is inheritance? So suppose I will create two more classes. Let me just create class student. This is a class student, and let me just create one more class over here, class teacher. Right. Now, so these two particular classes will have some properties, right? So what properties we can give them? So first we'll create constructor for both of them. For this, right? So let's just say a student has a property known as marks, right? So let's just give this dot marks equal to marks underscore, and let's just pass this underscore marks. All right, and a teacher can have a property known as student strength. Let's say student strength. So student strength is basically how much student does this particular teacher teaches. strength, right? So we'll say strength. Let's just give this strength. Right, and here we can also pass this as strength. Right. So these are the two more classes that we have created. So now in these two classes, what you can notice is that, see, this is a very separate property. Student strength is a very separate property. I forgot to add this over here. Yeah, this dot. So marks and student strength, these are the properties that only the marks are the properties that only a student can have. Class strength or student strength is a property that only a teacher can have these properties, right? But a student is also a person and a teacher is also a person. So they should have these three properties as well. That means name, age, and gender. These properties are common for every person, whether it is a teacher, whether it is a student, whether it is anyone, right? So instead of defining these properties over here again, that okay, take name, take age, take gender, right? Like this we will have to define, but instead of defining these properties over here, what we can do is actually we can say, hey person class, can you give all these properties to us? So there's a method of doing that, and that is basically known as inheritance, right? So see how we can do, how can perform in. So what I'll say is that class student, so I need these three properties from class person. What I'll have to do is I'll just have to say extends. So extends is a keyword that allows you to perform inheritance. And after this extends keyword, we'll have to say that what class are actually we extending. We are actually extending person class, right? We just go and we'll say person. Now what we'll have to do here is there is one more method that we need to call now. That is the super method. So inside this constructor, we'll just call our super method. So what does this super method do? So this super method is basically used to get the properties from its parent class. It actually, when we call this, so super method actually helps us to get all the properties from its parent class. Let's see how. Right. So here, what I need name, I need the age, and I need the gender. Suppose, not this dot gender, only the gender. Right? So these are the three properties that I need, and I'll have to pass this to the constructor as well, because whenever we'll create a student object or an instance, a constructor will actually run first and it will create an object for you. Right? So we'll actually get all these properties over here as well. So name, age, gender. Right, and now let's create a student object over here. Let me just remove this and let me create one student object for you. So what I'll say is I'll say let student equal to let student1 equal to new student, and now I'll pass all these properties. So now you have this constructor. Now this constructor has access to all these properties of this particular class. So for convention, let me just say these are all underscores, right? So you will know better that these are all the parameters, and according to these parameters we'll pass our values. What I'm actually doing is I'm saying that, hey super method, for all these parameters, whatever value we are passing, create these properties as well and pass these values. That's what the basic function of super method is. So now let's see that if we can create a student with name, age, gender, plus with his marks as well. So I'll just go here, I'll create a new student and I will say, let's name him Steve. And the second property is age. So let's give him 20. The gender is M. And the marks are, suppose he has scored 77 marks. So let's give this 70. And inside this console log, now we'll say student1. Let's console log this. Let's run this code. And now you can see, let me just clear all the output for you. And now let's just see. So now you have actually created a object from the student class, and now this object has name Steve, age, gender, and marks as well. It has all the properties that we were expecting out of it. Right? In the same way, you can actually do this with the teacher class as well. So let's see how we can do that. So what I'm thinking is that I will leave this teacher class up to you. Now you know that how you can actually create extend a class, actually inherit this property. So I'll let you try this one out, that please try inheriting all the properties from this person class to this teacher class. So what I'll be showing you now is I'll be showing you that how can you actually inherit methods as well, right? So there's a procedure by which there is a way by which you can actually inherit instance methods as well from one class to another class, from parent class to child class. So let's look at that now. What I'll do is I'll just create a method on this person. I'll just create a method on this person class. So how can you create a method? You very well know. So let me just say I create a method called welcome over here. And inside this, what we'll be doing is we'll just console log welcome to scalar, right? So now this is a method of class person. But now what we can do is we can just use this method here as well. So instead of welcome to scalar, what I'll be doing is I'll use the particular name. I'll use the particular name property. So you will have a better understanding of what you're doing. Let me just use template title and I'll say hello from name, right? So something like this, or we should say this dot name, because we are referring to the object over here, right? So this dot name. So welcome console.log hello from this dot name. So this method is of person, is of the class person. Now we need to inherit this. How can we do that? It's pretty simple. So as you know that you have already extended the class person, you have already inherited the methods, right? So it's no rocket science. You can just call them with using, again, you'll have to use a super method, but you have the access to those this method. So how you can do that? You'll just have to create one another method over here. Let me just name this method as test, and inside this what we can do, I can use super.welcome. Simple as that. And now let's just check that if this method is actually calling this method and printing the hello message from the name with the name or not. So let's we have already created a student, and after this console log, what we'll be doing is we'll call the method as well. So student dot, let's call the test method that we created, right? So let's see if it is giving us the expected output. So let's run the code, and now I can see the object is here and hello from Steve. Steve is the object. Steve is the person. Steve is basically the student, right? And he's saying hello. In this way, you can actually inherit your properties. You can inherit your methods from one parent class to different child class, right? You can actually do this with this class as well, or if you create one another class, you can actually do this with that class as well. You can actually then again use this class as someone's as some class's parent, right? So what we can do? So this much knowledge is very much enough for you to play around with everything, right? So this is all about inheritance in JavaScript. The next thing is we'll be talking about constructor functions. So let's move on to constructor functions. So let's see what actually are constructor functions. Right? So what I'll do is I'll just go over here. I'll just create one file over here as const.fn.js. So this file will be basically for your constructor function. So as we know that we can create classes, and based on those classes, we can create objects. But there is another way of creating objects in a similar way. But these are not classes. These are not function. This is the function method that we can. In JavaScript, basically, what happens is that we do not use that much of classes and inheritance and all. Right? JavaScript is more oriented toward function. So you'll always encounter more functions than classes or constructors and all. So this function is known as a constructor function because it actually has all the properties of this particular constructor. Right? And now let's see how we can actually create. So what we have to do is, this is pretty simple. If you have understood classes and all, you'll have no time to understand. So what we can do is we can just create a function over here, and let's just say that we take the example of car. So I'll say function car, and inside this what I will do is I'll say that this function will have some properties. So I'll say this dot name, and here I'll pass name. I'll say age. Oh, sorry, this is car. Car won't be having an age, right? So name or color, let's say. Right, so I'm just passing two values. You can pass the top speed. So top speed. I'll say this dot name is basically the name. Then I'll say this dot color is basically the color parameter, and then this dot top speed will be the top speed, right? So now you can see that I have created a function car, and inside this I have just written all this stuff. So you can actually match this with this constructor. Isn't it? Aren't they looking pretty similar? Aren't they looking the same exactly? Right? Let's check for this one. Classes, right? This one is the constructor. So let me just pick this code up, and let me just paste this over here for now. Just pasting it over here. So now you can see that pretty similar, almost the same. Just we are using a function instead in the place of constructor over here, right? So this is how actually a function can be created also, and this will totally work like a constructor. You will not be needing to create classes over here. That is the benefit of using constructor function. So now we have created this. How you can use this function? I can use this function pretty simple, right? The same way you were using the constructor, the same way you were calling the constructor, in that way you can use this. You can use this function, right? So let car1 equal to new car, and pass anything. I mean, pass the values that you like. Okay. Now let's see if it has been created or not. Run. You can see that your object has been created. This is basically a constructor function. So now if you have understood classes, you know that inside classes we use a constructor that does the work for us, but this is actually a constructor function that will do the work for you in the pretty similar way, in a pretty similar way, or almost the same way, because inside this function also that this keyword is actually creating a empty object first and then putting your values inside of it, whatever you are passing inside. We have discussed this. This is how you can use your constructor function as well, and this method is more preferred nowadays because no one is using classes and constructors, and basically the syntax gets a little clumsy. So this is a better way of doing that. You can also like inside classes we were defining methods, you can also define methods over here, but here the catch is that you will need to add this keyword with your method. So what I say that this dot drive, I'll have to add like this, and inside this I'll add a function, because obviously we're creating an object over here, and here we don't have the constructor method, the class, right? So here we'll have to work according to the object, right? Like we're creating an object. So what we're doing is we're actually creating this key, and inside this key we're passing a function. So I'll say that in this key we'll have a function, and I'll just say console.log I am driving at top speed, or I'm driving let's just take the name for this time. And how can you call this method? You can just call this method by referring to that object that you have created, and you can just say drive. Simple as that. This is on the code, and now you can see, oops, an error has encountered because I am driving a name. All right, so I'll have to pass this dot name, right? Because we're obviously referring to that object. Let's run the code, and now you can see I am driving a Ferrari. Like that, if you create one another object in a pretty similar way as we have done in the classes thing, right? Then you can actually go over here, you can change these values to BMW, blue, let's just keep it 450. Let me just comment this out and let me call this with car2 here. Now I can see that I'm driving a BMW, right? So this is how you can actually create a constructor function. You can use your methods, you can use your properties, and by the same way you can create your objects and you can call them. In this video, we'll be talking about prototype and prototypal inheritance. So this is one topic that actually confuses a lot of JavaScript developers who are actually beginning their journey right now. I can be sure after watching this video, you will be really familiar with this particular concept and you won't be having that much trouble understanding it further. So let's see that what we actually mean when we talk about prototype and prototypal inheritance. So what I'll do is I'll just go over here and I've created one file, proto.js, in this particular folder. And inside this, we'll be talking about prototypes and prototypal inheritance. So what I'll do is that to understand prototypes better, what we can do is we should be viewing this in the browser, right? So what I'll do, I'll just go into this index.html file and I'll link my prototype file here, that is proto.js over here, right? And now what I'll do, I'll just come over to this file and I'll just create a new object and I'll say let this be an empty object. So this is an empty object. I've created an empty object over here, and then I'll say console log this particular object. All right. Now let's go back to our browser and see that what output we have got. So I'll just go over here and I'll say open it with live server, so that it will open this particular file on our browser, the HTML file, right? And then what we'll do is we'll just go to inspect and on the console to view the output, that what output we have got. So basically we have an object over here, right? But this object is empty right now. So let's open and see that if this object is empty or not. This object is empty. We do not have any key value pair. We do not have any value stored inside here, but you can see that there is something known as prototype that we can see with this object. And now this prototype thing is also an object. If you go over here and if you open this up, you will see a lot of methods, a lot of properties defined over here. So let's do one thing. We'll go back again and inside, right? And now what we can do is we can just go over here in our proto.js file and I'll define one more object. Let person1. I'm defining an object for a person, and this person, sorry, this is an object, not an array, and this person will have name. So let me just pass any random name, any random age, and now let's see that what we see when we console log this particular object, person1, right? Let's go back to our console and see. Okay, so we're getting another object. The first object is actually empty, so you can see over here. The second object is that we have got the name and the age property. Now let's open this up again. So when we open this up, we're getting the age and the name property, but with these two particular properties, we're again getting a prototype object. So let's see one more thing now. We'll be using one method with it, right? So the method is basically the hasOwnProperty method. And inside this hasOwnProperty method, what we'll be doing is we'll just pass person, we'll just pass the key name, right? So what we can do is let's pass name. So what this particular hasOwnProperty method does is that it will actually search for the particular key inside the object for which the function has been called, right? So we are calling this for the person1 and we're searching for name. So if any name property exists inside the person object, inside the person1 object, so it will return true. So let's just check if it's returning true to us now. So you can see that it's returning true, right? And then what we can do is we can pass any other key and we can check that if that property exists or not. So name and age exist. So what I will say that I'll say gender. We have no key as gender over here. So what it should return? It should return false. So it's returning false now. Have you defined this particular method or function? No, this is inbuilt, right? JavaScript is actually giving this function to us that, okay, this hasOwnProperty is my method, but you can use it. So this must be defined somewhere. This must exist somewhere. If you now look closely, so let me just console log this person object for you as well. Again, right? And let's check. If you now look closely, you will find that inside this object, inside this particular prototype object, we have this hasOwnProperty function defined. If you open this now, and if you go to its prototype, so you will see that it has a lot of things inside it also. This has one property is basically a function which is already defined in JavaScript for objects. Whenever you will create an object, this prototype object will always get linked to that particular object. So from inside this prototype object, you can use every one of these properties and methods. So there is has one property, there is toString, right? So there are a lot of methods which you can use for a particular object. This is what your prototype object is, right? So what is a prototype object? A prototype object is basically an object that gets linked to your object by default whenever you create an object, and inside that particular prototype object you will find all the methods that you can use with your particular objects. So this is what prototype is. All right, so after basically discussing about the prototype object, now let's see one more thing. All right, so here we have actually defined our object in a pretty simple way, right? As we define an object like my object and just the curly brace. But what if we try and we define one object for us by using constructor function, right? So let me just use one constructor function over here. Constructor function. If you're not familiar with constructor function, classes, constructors, so I'll strongly suggest you to watch our previous video on classes and constructor functions, right? Alright, so let's move ahead. So when you actually use a constructor function to create an object, what you do is you just say that let person, and inside this person, what I'll say, I'll just create one function, or let's just create a function as in the orthodox way, in the basic way, right? I'll just create a function for person. For this particular function, what I'll say that, okay, have this dot name as underscore name, and I'll just pass underscore name over here. And let me just say that, okay, so you'll have age also. So let me say that this dot age equal to underscore age, and I'll pass one age parameter over here. So these are the two keys that this person will have. Any instance that will create for by this particular person function will have these two properties. So how will you create an object from this constructor function? You will just say let person2, because we already created person1, so I'll say person2 equal to new person, and for this new person I'll pass name as Steve, and I'll pass the person's age as 30. So, and let's see that if we are able to create this person2 object or not. So I'll just say please console log the person2. Let's see that if it has been created or not. One person object has been created with age 30 and name Steve. And again, we have this prototype over here. But let's open this prototype now, right? Let's open this prototype. So when I open this particular prototype, you see that we're again getting another prototype object inside this. But when we were opening this particular person object, which we created in a pretty the simple way, right? When we created an object in a simple way, we were seeing that, okay, this particular prototype object has all the methods listed over here. But when we're actually using this person object over here, you see that we have one prototype object, but inside this prototype object, we do not have these methods. We just have this prototype object, and inside this prototype object, we're again getting one prototype object. So now when you will open this particular thing, you will see your methods and all your properties. But why is this happening? When you are actually using the simple object creation method, you are seeing that, okay, one prototype is attached to that particular object, and inside this you have all the method. But when you're using a constructor function, you're getting a prototype, and inside that prototype object, you're getting another prototype, and inside that prototype object, you're getting all your methods and all your properties. So this is where people get confused. This is where all the confusion happens. So let's understand this particular behavior in a little depth, right? So I'll just come back and I'll just open everything for you again. Here, this and this. So let's see that what is happening over here. So if you see that for this particular object, which we created for person1, you can see that the prototype we have is for the object. This prototype is for the object. Which object? This particular object. So that's why it is written object over here. But when you actually see for this person prototype, you will actually see that this prototype is for this person, because inside this prototype you have a constructor, and this constructor is for this particular person. And then inside this prototype, this particular prototype is for your object. So what is happening over here is that when you're actually using a constructor function, or when you will use a class to create an object, what you will see that the particular object that you will create will have its own prototype as well. So this prototype is by default for an object, but this prototype now is for your object that you have created, right? So this is where it gets tricky, right? So let's go and see that for all for this object and this object, why this difference is coming and why this behavior. Let me just open the open board right over here, and we'll understand by a graphical representation that where and how all the prototypes are getting created. So let's see. So now let us try and visualize actually what is happening. When you're creating a simple object, right, with the syntax and all, the simple way, you're creating an object, and that object is getting an object prototype. That is basically pre-built. It is getting attached with your object by default. So this much is pretty simple. So this object prototype is getting attached with this particular object that you're creating, and it has all its pre-built methods and properties that you can use with this particular object. But when you're using the constructor function, what is happening is that suppose we are creating this constructor function for a person. So what will happen is this constructor function will actually create one prototype over here that is of person type. So you will get a person prototype over here as well, which is specifically for the object that will get created with this particular constructor. But not only this, this is also an object right now. So your object prototype will also be here. That is pre-built. So this prototype will also be here. These two prototypes will be connected to each other. So see, what will happen over here is, I should make this arrow as this. Alright. So now what will happen over here, that whenever you will create this particular person object from this particular constructor function, you can create several persons, right? You can create several objects for this particular person. So what I'll do is I'll just say, let me just say I created one object as person 1, I created one object as person 2. So all these objects will have their links to this particular prototype. And inside this prototype, as this is created for this particular object only, this particular constructor function only, what you can do is you can actually initialize your methods. You can actually create your own methods, and you can put inside this particular function. So let's suppose that I create one method over here, and I say that I've created one method as greet for this particular function, for this particular prototype. So this method will get attached to this prototype. As you saw that this particular object has all the methods, like has own property, to string and all that, which are pre-built. But now you can create your own methods, right? So I've created one greet method over here, and I've put inside this person prototype. Now, whenever I'll use this person object or these person objects that I've created from this, I can use this particular method, and this method will be called from this person prototype. And what will happen? So if I call that has own property method now, so what will happen, that this particular person will actually try to find that has own property method first inside its person prototype, inside its own prototype. Here it will not find that has own property. So what it will do, it will go to this object prototype now and try to find that method, and it will find that method and it will call it. But now suppose that you have passed any method that doesn't exist in this person prototype and that does not exist in this object prototype as well. So what will happen? Basically, there is something known as a null container. So this null container doesn't have anything that this object prototype is connected to this. So it will try to find the method in this null container as well, but this null container has nothing. So what it will do, that it will pass error. And that error you will get. If any method doesn't exist in this person prototype or in this object prototype or in this null container, it will just pass you an error. So in this way, what will happen is that you will get an object prototype by default for every object, but when you actually try to construct a function, right, you will get another prototype, and this prototype will be available for you to use. You can pass any method, you can create your own methods inside of this prototype, and you can use this for this particular object. This is a constructor function through which you are creating this object. So you will be able to create all these methods. You will be able to use all these methods inside this person prototype for all these objects. This is why another prototype gets created. This is for you to use, right? This is for you to use. This is basically by default. It is made by default, and you can use all those methods that are pre-built inside this. But this is your custom prototype. You can say it like that. This is your custom prototype. You can customize your object. You can set your methods. You can set your properties for this particular object inside this person. This is why a new prototype is getting created. It is for you to use. So now, if you're clear with this, let's go to our code and understand it, how you can actually initialize your properties, how you can actually create your properties and methods inside of this prototype. So let's go to our IDE again, and we'll look after that. Just want to add one more thing over here, that if you see all these links, so this is one link, this is one link, and this is one link. So all these prototypes are linked with each other. Person prototype is linked with object prototype is linked with this null container. So what is actually this thing? What do you call something which has several links? A chain, right? So this concept is basically known as prototype chaining. Right? This is a very important interview question as well, and you should know if you are actually a JavaScript developer. If you are trying to learn advanced JavaScript, you should know this particular concept. What is prototype chaining? So you can see that this prototype is linked with this prototype is linked with the null container, right? So okay, this is not a link, this will just throw an error, right? So these are the links. So it is a chain. So this is known as prototype chaining. One or more than one prototypes are getting chained with each other, then that is basically prototype chaining. Two or more than two basically, right? Because you will need two links to create a chain at least, right? So this is how your prototypes work. Now let's just go into our code and understand that how can you create your methods inside of this prototype. Let's see. All right. So now let us understand that why do we actually need to create methods inside prototype, right? We'll be creating all our methods inside that particular person prototype object. Why do we need that? We can just create our methods inside this constructor functions as well. So let's take an example. So what I'll do is I'll just go and I'll create one more file over here. I'll say proto2.js, so that we'll have all the clarity from the start, right? And I'll just link this proto2 over here, proto2.js, right? And let's start working on this. So what I'll do is I'll just create a function, and I'll say that, okay, again, a person function, and I'll say this dot name equal to let's say that name, right? Then I'll say this dot age equal to age, and we'll pass age over here, something like that, right? Okay, and now let's define one method over here. So what I will say that the method's name, okay, so we can keep any method. So I'll say this dot get name and age, right? So this dot get name and age. So this is the one method that we will be defining. So for this method, what we will do is we'll just say function, and inside this we'll say console.log this dot age. Let's use backticks over here, and we'll say I am this dot name, and my age is something like that, right? So pretty simple constructor function, which will actually create an object with its name and age property, and it just has a method which will just get the name and age. It will print the name and age of that particular person object. Now let's just create one object with this particular constructor function and see how you can actually set your methods inside of a prototype, right? Let's see that. So first let's understand that how basically this constructor function will create its prototype. So let's just go to open board once more, and I'll go to another page. Okay, so it has been closed. I'll open this again. I'll say open board, and here we are. So what we are actually doing is, suppose that we have created one constructor function. So now we have this person. Now we had this person constructor. Now what will happen is that one prototype will get created for this particular person constructor, right? Right now we haven't created any object for this, and by default your object prototype will be here. That is, you are getting from JavaScript, right? Which is your default prototype for any object. Now let's suppose that we create object with this particular person constructor. So let's go back and let's create an object. So what I'll do, I'll just say let person1 equal to new person, and it will have a name as Adam and it will have age as 25, suppose. And now let's create one more object with this person constructor, that is new person. I'll say Steve, and here let's just pass 30. So these are the two objects that we have created. So now what will happen is that as we have created these two objects, now I have created person1 and I have created person2. These two objects will get linked to this prototype person. So now this way, this prototype person will be linked to both these objects. And this object prototype is already linked to this prototype person. So in this way, a chain has been created, right? So this person attached to this prototype and this prototype person is attached to your object prototype. So this is where you have created a chain. Now let's see. Let's just go into our index.html and we'll try to run this code and we'll try to see our output. So let's just go to index.html. Let's open this with live server. So here we are. Let's go to inspect and let's console. Let's see console. All right. So we do not get anything. Why we didn't get anything? Let's check. Because obviously we haven't console logged anything. So let's just console log person1 and person2. Just a second. Person1 and person2. Alright, and now let's just check in our console. Okay, so now you're getting your person and person. So there are two objects with this particular constructor which I have been created, right? The name Adam, age 25, name Steve, age 30. But see over here, right? What you are getting over here is you're getting get name and age as a function, and you're getting get name and age as a function. See, these are your keys. Name and name are keys, but their values are different. This is age. The key is same, but the values are different over here. But if you look at this get name and age, you will find out that the get name and age thing is same for both the objects. Is this the right approach to actually incorporate a function inside object? I don't think so, because we are actually violating the dry rule. What is the dry rule? The dry rule is do not repeat yourself. Whenever you're programming in any programming languages, there is a rule that is known as the dry rule. So dry rule basically states that you should not repeat your code. You should actually have your code modular. You should actually create functions just one time. But here what we are creating is that we are actually creating two objects, but with these two objects you will have the name and age property different all the time, right? But this function thing, this function property will not be different, because function is a function. That is a body, that is a whole body. So what you're doing is you're actually providing that function body two times to an object. If you create multiple objects now, just imagine how many function definitions you will create for every other object. Is this the right way? This is totally not the right way. So what we can do is we can actually incorporate this particular function inside the prototype. So what will happen is, just suppose that if we look into this chart, so what we are actually doing is we are giving name, age and function to this person as well. We are giving name, age and function to this function as well. So these two properties are different. These two property values are different. So we are not violating anything over here. But this function is getting to both the objects, right? This function we are actually repeating. So suppose if you create person3 and you pass your name, age different with different values, but you will again pass your function as it is over here. We are actually repeating ourselves. So what we can do is we can just say that, okay, let's just not keep this person thing. Let's just not keep this get name and age function inside these objects. And what we can actually do instead of that is we'll just put that particular function over this person prototype. And we'll say that, okay, hey, person1 object, hey, person2 object, hey, person3 object. You just take this function from this person prototype. So in this way, what you're actually doing is this person prototype is linked with all these three person objects, right? So they will be actually able to get this particular function from this prototype. So we'll just say that inside this prototype, we'll put this function, that is your get name and age function. And we'll just say that, hey, use this particular function from this prototype. So now let's just see that how can you actually create a function, or how can you actually put a function inside your prototype object. Let's see that. So now let's just see that how you can put this particular function inside the person prototype. So you do not need to do anything. Do not need to do anything. If you have noticed that the prototype of this particular constructor function is getting created by this name only. So what you have to do is you just have to use this particular name which your constructor function has, and then you have to say that okay, person dot, and you will have to say prototype, right? Person dot prototype. And after this, just take this whole function definition with you without this keyword and copy this. And after a dot, you can just say that, okay, do this for me. Right? So what we have done is person.prototype.get name and age equal to function. So what we have done is we have basically defined one get name and age function inside this prototype. And now we can remove this from over here. All right. So now what has happened is, if you notice that whenever we'll be creating 1%, person 2, person 3 objects like this, let me just write this clearly over here. So now we have one person 1 object over here. Now we have this person 2 object here. Right? And let's suppose we have a person 3 object here as well. What will happen is that this function get name and age will get linked to all these objects. Will just get linked to all these objects. Mark my words, what I'm saying will get linked. So it will not actually get repeated. It will get linked. So whenever we'll create person 1, okay, so the prototype has the function get name and age of person 1. Person 2's prototype has the name, has this function. Person 3's prototype has this method, right? So let's just see that in by actually console logging all these persons, and let's just try and see that if we are getting this get name and age function inside the prototype of this person or not. So I'll just go back to browser and let's see. Inside this person, you do not have that function. Inside this object as well, you do not have that function, right? Let's open this object. And inside this object, you have this prototype. Let's open this prototype. And now inside this prototype object, you have this get name and age function. Let's check first the second object as well. Inside this prototype object, you have this get name and age function. So now if you see that, okay, some people can have this question that, okay, hey, inside this prototype, we have function. Inside this prototype, we again have this function. Aren't we again repeating ourselves, right? So aren't you again violating the dry rule? But no, we are not, because here we're actually not repeating this. We have just incorporated that method inside the prototype, and we are just asking the prototype, hey, that whenever we'll create an object, please give us this function with that particular object. So you're not repeating it. It's just inside the prototype. It is not getting created repetitively. It has been created only once. We're just using that method, right? Like with any other method, if you see that inside this prototype also you have your has on property. Inside this prototype also you have your has on property and other properties. Similar to that, right? You're actually creating your own method for a objects prototype, right? And now let's try and let's see that if we can call this or not. So what I'll do is I'll just go inside this person one and I'll say get name and age, and let's see if we are getting the the name and age for that particular object. We are calling this for person one. So this method is also attached to the person one's prototype. So it will call the method for this person one, and the values of person one is Adam and 25. So we should get Adam and 25 on our console. Let's see. So we're getting I am Adam and my age is 25 over here. So in this way, you can actually use prototypes from with different objects, and you can actually incorporate your methods, your functions, your properties. You can also set some default properties that your objects will have, so you won't have to repeat all that, right? So this is how prototypes actually help you to write code better in JavaScript. In this video, we'll be talking about 3 of the most important methods that you should know when you're working with object-oriented JavaScript. And those 3 methods are call, apply, and bind. So now we'll actually see that how these 3 methods work and what problems do they overcome and why should you use them. So before going to call, apply, and bind, let's see that why do we need these 3 methods. So here I've actually created one file called apply bind, and inside this file we'll be talking about all these 3 methods. So let's start. So first let's take an example and see that why do we need these methods. So let's see that I'm creating an object over here, right? Let me just create an object. I'll say person1. And for this person1, what I'll do is I'll just give this person some properties. So let me just say first name. First name will be Steve, suppose. Last name, let's give this Rogers. So we have Steve Rogers, right, as our first person. And let's pass a age value, suppose. So let's pass 102 over here. All right. Now what we can do is now let's just write a function for this particular object. What I will say is print details. This will be a function and this will actually print your details. So let me just console log over here and I will say that I am Steve Rogers. So I'll have to take this dot first name and then I'll have to take this dot last name. And then I'll say I am this much years old. So this dot age years old. So this is my first object, a pretty simple object, right? So here, if you haven't watched the video on this keyword and if you don't know how to create objects, right? So I strongly recommend you to watch our previous videos where we have discussed about objects, where we have discussed about this keyword. We have discussed all these topics very deeply. So you can check out those videos and then you can come back. So let me just quickly go through this. What we are doing here is, so we are creating an object over here. We are defining a method. Print details is a function. When we'll call this function, it will actually take the this dot first name, this dot last name, and this dot age. So whenever you use this keyword inside an object, inside a function, right? So basically what it will do is it will start pointing to that object itself. So what you are actually doing is when you're saying this dot first name, so we are actually getting this first name value from this particular object only, right? And same for last name, same for age. So what will be our expected output? The expected output for this will be I am Steve Rogers and I am 102 years old. So this will be the output. So let's see if we're getting that output or not. Alright, so let me just clear this once for you and let's run the code. So here you can see I am Steve Rogers and I'm 102 years old. This is how you can create an object and you can use all these keywords. Okay, so this was pretty simple. Let me just create one more object over here and I'll say person2. And for this person2, I'll copy all these things and I'll just paste this inside here. And I'll just change the values over here. So I'll say Tony Stark. So we have Tony Stark over here, who is, let's suppose he's 41 years old. And then what we can do is print details. This will be the same function. And then let's call this for person2 as well. Right? And let's just run the code. So now you will see that the code has been executed and we have all the details of the first object and the second object as well. Seems pretty easy, seems pretty reasonable that, okay, this is how this should work. But if you see here that what we are doing, that first name, last name, age. So we have the same keys, but for the same keys, the values are different. Here Steve Rogers 102 and here we have Tony Stark and 41 for the same keys. But if you see that this print detail function, we're actually repeating this function again. So here you don't see any difference because this function and this function, they both are pretty similar. So we are actually violating a particular rule over here, that is the dry rule. The dry rule states that you should not repeat yourself. Do not repeat yourself. The dry rule, right? But we're repeating over here. Like we are creating two objects and we are creating these two functions for them again and again, right? Suppose now we have to create some more objects like this only, right? So we'll have to keep the same idea of these objects, first name, last name, age, and the function. So what we'll be doing is, okay, so we will be assigning this first name, last name, age different values so that we are not repeating them, but this print details will always be repeated with every object. So what we can do here is that one solution is that we have discussed in our classes and constructors video, that what we can do is we can just create a class and from that class, we can create different objects or we can create a constructor function or from that constructor function, we can create different objects. And then inside that particular object's prototype, what we can pass is that we can pass our method and we can call those methods for different objects that we'll be creating. So we're not repeating any function or any method. We are just calling that function from inside the prototype and we are using this, right? If you haven't watched the prototype video, I'll strongly recommend you to please go and watch that. So you'll have a better understanding of what I'm saying. But that solution won't work here because here we are not using any classes or here we are not using any constructor function. Here we are creating the objects as they are created, right? By using this curly braces and creating different objects. So what we can do here so that we do not have to repeat these functions for every single object. So this is where the call methods come into picture. So now let's discuss the call method. So what I'll do now is, see, if we have some way that we can use this particular function for this object as well, but without writing it here. How can we do that? That is the question. So let's see how can we do that. So what we'll do is we'll just go over here in the call method. Down here, and what we can use is we can use this person one, right? So let me just remove this method from here right now. I'll remove this function from here. So now we don't have any function like print details for this person two. So what we can do is we can ask this person one that, hey person one, can you give us your print detail function? So now we have our print detail function, and we will call this, and we will call this for person two. That's it. So what will happen now is that this keyword that we are using here, so when you are calling this print details for person two, will start pointing to this particular object that we have passed inside the call method. So now whenever we will call this print details method for person two, this keyword will start pointing to these particular values, right? So let me just comment these two calls and let's see what this will give us the output, right? Let's see, run code, and now you can see I'm Tony Stark and I'm 41 years old, right? What we are doing is we are actually borrowing the function from the person one. We are saying that, hey person one, give us this particular function because we need to call this for another object, and then let's call this for person two. So now this keyword will start pointing to these particular keys and basically these particular values, and you'll get your desired output, right? So this is how the call method works. Now let's see what actually is the apply method. All right. So now moving ahead with the apply method, what I now want to show you is that suppose we do not want this particular function to be dependent on this particular object, right? So what you are noticing here is that we have to call this particular function from inside this object. So what we can also do is we can just bring out this function outside of this object and make it global. So now here the object syntax won't work. So I'll have to just say let print details, and I'll just add an equal to over here so that it becomes a function expression, right? Now what you can do is this is a function now. So now what we want to do is that we want to make this function globally accessible to every object. Now if you see that I will remove the person one from here, and I'll say, okay, call this print details and then print this first name, last name and age. So now what will happen is now this particular function is not dependent on this object. So it will run again. So you can also create your functions and then you can call these functions for different objects, right? Regardless of if they are off from some object or if they are written them globally, right? So you can do that as well. Plus, you can also actually give some parameters to this function. So let's suppose that, let me just remove this particular line from here. And what I will say is, or let me add one parameter over here. Let me just add one state, right? And I'll say I am from, or let me add the city over here. City. So here I'll just pass city. So now what you can also do is that when you're calling a particular function with this call method for a particular object, you can also pass the parameter that is expected on that function right after you have defined this object, right? So let me just pass city's name over here. So I'll pass New York, right? So what will happen is when we are calling this function that is print details, so this particular argument here is for this particular parameter. So what will happen is Tony Stark and 41 will get printed for all these things. And in place of this city, what will you get now? You will get New York because you're passing this as an argument to this particular function. Let's just run this and see if we're getting that. Let's run the code and now you can see New York over here. And not only this, you can pass multiple parameters and multiple arguments. So I'll just pass city and let's just say power. So the power is the Iron Man armor. So I've passed over this, I passed this here, And now what you can see is, let me just write my power is, I have the, right, as this. So we have passed iron man armor. So let's see, run this code, and now you can see that I am Tony Stark and I'm 41 years old. I'm from New York. I have the iron man armor, right? So this is how you can actually use your call method with multiple arguments and multiple parameters. Right? So let me just place this nicely, and now you will have it as you want it to, or I should place it here. Yeah. So this is how you can get your output. Right? But now we're actually trying to discuss the apply method. So what actually apply method allows you is that if you're passing your arguments over here for these parameters in this way, if you use the apply method, so let me just use the apply method for person one, right? So I'll just use this, I'll copy this thing, and I'll just replace this call method with apply and let it be for person two only. When you're using the apply method, what you're expected to do is you're just expected to put your arguments inside of an array. You cannot directly put your arguments over here. You will have to put your arguments inside of an array. That's the only difference between apply and call, right? So you'll have to put these two values like this inside of an array. So when you will put inside of this array your argument, then only the apply method will work, right? So let's just run this code again, and now you will see two outputs, right? So one output is from the call method, one output is from the apply method. So this is the only difference between call and apply, that when you use the call method, the arguments that you pass can be without an array, you can just directly pass this like pass your arguments like this. But when you're using the apply method, you will have to always pass your arguments inside of an array. If you're not using an array, so see what will happen. You'll encounter an error, right? Because this is basically create list from array like. So this is basically your error, right? So you will always have to use an array when you're using the apply method. So this is the only difference between call and apply. Now let's see what actually is your bind method. This is your apply, and let's see what actually bind method does. All right. So bind is actually nothing. Bind is just a method which actually allows you to store your function and to call it at a later stage of time, right? It basically works as call only, but just one advantage, one added advantage of bind here is that whenever you will try to call, like let's take it with an example. So I'll just copy this and I'll paste it over here. And what I will say is that I'll just use bind over here. Now what I am allowed to do is I can actually store this particular function, right, which is actually your sprint details function for the person to in a particular object. So let me say that my function, and inside this particular variable I've actually stored this particular function. Now let me just console log this for you so you can clearly see that what has been stored inside my fun. And let me just comment these two things for now. Let's just run this code, right? So now you can see that function has been bound. Function has been bound. Print details function has been bound now. So what it means that it has been stored inside this particular variable, and whenever you will call this particular variable, this will invoke that particular function and it will provide you with your desired results. Whenever we'll run this code, now you can see that again that particular output is here. This is the only added advantage of bind, that it actually allows you to store your function on a different variable so that you can call it at a later stage of time. You can invoke that particular function at a later stage of time whenever you require that particular output. So this is how you can actually use these three methods. One is the call, other is the apply, and bind. So basically, let me just rephrase this for you quickly. So call method will actually help you to get or borrow a function from another object, or you can also basically write a function globally, right? And you can use this function with different objects by using call in this way, right? You will just have to pass the object's name whenever you will call the function with the function, right? And that particular function will be called for that particular object. Right? Then you can use apply. The only difference between call and apply is that we'll have to pass your arguments inside an array, right? And then there is the bind method. The bind method actually allows you to store a function in a specific variable, and then you can actually call it at a later stage of time. So these are all these three methods. They come in pretty handy when you're actually working with object-oriented JavaScript. Yeah, so these are the three methods that you must know in object-oriented JavaScript. I hope you liked the video, and this was it for this video. And if you like the video, do like this video, subscribe to our channel, share with your peers, keep watching Scalar. We'll be soon coming with more interesting topics. Bye-bye. See you later.